This conference will now be recorded.
My name is Srinivas Reddy. Okay, those attending online, there is an option to make the screen full. When you in the top of the screen, there is an option hide everyone. There is a drop down menu where you can see an option to hide everyone. Do you see that in that GoToMeeting application? I hope everyone got it. There is an option where you can drop down and make it hide everyone. Then the screen will come in full screen mode. How about others? Okay, fine. Thank you, Shlok. Okay. So as Shlok suggested, press F11, probably it will become full screen. Okay. So let us start with the session. As I was telling, my name is Srinivas. I'm the founder of the institute. I handle the front-end training related activities at the institute. That is starting from RTL design, integration, and functional verification. And I also have expertise in the other aspects of the front end. That could be the standard protocols, the SOC verification, low power verification, the processor architecture to an extent, where I also handle advanced courses. I do regularly do corporate training to the companies. Okay, now coming to our session, today's session will be the front end training demo session. Uh, First, let me go over the agenda. Then I'll be explaining. I think some of you are here attending DFT training demo session. Some of you are attending functional verification training demo session. Another 5-10 minutes, you will get a clarity about what is this demo session is about and when is the DFT specific demo session will happen and everything. Okay. So we'll be starting off with understanding the start off with understanding what all courses we are starting today. The institute overview. We'll try to understand some basics of electronic systems. Then we'll try to understand what is the difference between VLSI and embedded systems. Then we'll try to understand the different steps in VLSI design flow. Okay, what is mean by front end domain? What is mean by back end domain? And what is the kind of skill set you require in front end domain and back end domain? We'll try to understand. Okay. Then we'll understand the VLSI domain, different job roles. Like in software, there are only three job roles are there: architect, the developer, and the tester. So for you, making a choice is very easy. In case you want to get into a software job, just have to choose whether I want to be a developer or I want to be a tester. When it comes to VLSI, you will see that there are almost 15 different job roles are there. Each of them doing a different work. Someone is doing physical design, someone is doing functional verification, someone doing DFT. They are completely different role. Let's say I'm into DFT. Probably throughout my career, I will only do DFT. So it is important now for you to understand the VLSI design flow and understand what is, which domain will be interesting for you and choose the domain accordingly. Okay, I'll keep the session very basic. I'll try to explain things from basics. The way we do the training. When we start the training also, we don't assume that you come with any basic skill set. Okay, only thing we expect is the right attitude and the aptitude. These are the only things that you should come with. Everything else will be covered from the basics. Now coming back to the agenda, what is the skill set required for different job roles in VLSI domain? Then how do you choose the right domain? Then we'll talk about the institute facilities. Okay, how to prepare for the job roles and why career in VLSI. Then the placements at the institute. We'll also talk about the questions. I'll address any of your questions. I am the founder and I have a dual degree from IIT Madras. I have worked in the industry from 2005 till 2019. That is around 14 years I have worked. Parallelly, I was also uh, doing the training starting from 2012. Yeah, please come. So starting from 2012, I have been doing the VLSI training. So then in 2019, I have quit the job and I'm full time into the training. We had started, I mean, like every business, every institute, every educational facility starts with a smaller number. Let's say we started off as a 3 people batch or 4 people batch. The intention with which we started, because I was already working, we had a decent salary. So the intention at that time was to provide a quality education which is affordable. Even then in 2012, back in 2012 also, the average fee in the institute used to be around 1 lakh. I mean, there used to be only 4 5 institutes at that time, not so many what you see today. Even then it used to be 1 lakh plus or minus something. Okay. Then we had set up the course with around 25,000. Okay. Because for me, it was all the spending my weekends on a, I mean, utilizing my weekends and have some income. Okay. So that is where we had started off that program. And now we have grown to a stage where we train almost 2,000 people in a year. Not all 2,000 are not freshers. Out of them, almost 1,200 people are working professionals. Now we have a lot of other courses. I mean, we offer, other than the courses that are meant for freshers, we offer many other courses on standard protocols, SOC verification. There are many other aspects in the VLSI itself where we have many enrollments from the working professionals. Okay, that is where we have reached. Okay, uh, I also do corporate training. I told you, right? We have courses meant for working professionals. Because of that, I do corporate trainings on a regular basis as well. Okay. The corporate training, just to summarize, it's the training that we go to a company and give to the employees of the company. Okay. There we don't have any obligation of placements. It's just the delivery of the training is what we do there. Okay. Now, let us talk about what all courses are starting today. Generally, what we do is that we offer many courses in VLSI design flow, like starting from RTL design, RTL integration, functional verification, 3 domains, then the physical design, DFT, custom layout. Like that, there are around 6 7 courses we start, even FPGA training. We can't have a different batches, starting dates and demo classes for everything. So what we do is we have 2 demo classes, one for front end domain, the other for back end domain. So today what we are doing is the demo session for front end domain. The tomorrow we will be having the demo session for the back end domain. In case you want to get an exposure to what is back end domain, you can also attend that either online or offline, so that you understand what is what. Okay. Now let me go into this. Okay. So first of all, the one of the course we are starting today is RTL design and functional verification. Same course, this course is same as front end training for freshers. It is same as functional verification training for freshers. It is same as ASIC verification. Please come to the front. So whatever course I refer here, it's all the same course we are talking about. Other than that, we are also starting the same course for experienced engineers. Means sometimes the people who are working in the industry, you may ask someone who is already working in the industry, why does he need this course? So many times it so happens that those who are working in the industry, they don't get that in-depth exposure to the entire flow. Let's say we are talking about functional verification. As the term suggests, what is meant by functional verification? We are verifying the functionality of a given design. Okay, the design could be a mobile phone, design could be a laptop, design could be a router, can be any electronic circuit. When the designer, what we call as RTL design engineer, develops the Verilog code for that. The RTL design engineer uses Verilog language to develop the code. It is prone to errors. I mean, there can be some issues in the code. Unintentionally, he might have done the mistakes. So the role of a functional verification engineer is to catch those issues. So I was talking about functional experience engineer, right? Now many times those who are working in the industry, they don't get to work on the entire flow. So that is where our courses helps them fill that gap as well. Now you may ask, what is the difference? The difference will be, here we'll be starting off with the basics of, I mean, in these courses we'll be starting off with the basics of digital design, Verilog, system Verilog, everything. When it comes to experience engineer, we give them flexibility to start the course from system Verilog onwards itself. They can skip digital and Verilog. For them, UVM course will be more advanced compared to a fresher. There will be one topic called as UVM, which stands for Universal Verification Methodology. Okay, don't get frightened by the names. They are very simple. It's just that you need to spend time. In the term Verilog, System Verilog, UVM, when you spend time, you will find the ease with those courses. Okay. So for them, we cover this UVM in more advanced manner. Okay. Okay. Then we are also starting the courses today for Verilog for design and verification and System Verilog for functional verification. These two courses are mostly meant for people who are pursuing their BTech and MTech currently, because when they are pursuing, they already have their semester work, so they won't have time to attend the full-fledged course. So we give them flexibility to attend the smaller courses to improvise their skill set. Mostly these courses are meant for people who are looking for internship opportunities. It really helps them. Then we are also starting a course on FPGA design verification. So what is FPGA? How does it differ from ASIC? There are two VLSI design styles. One is called as ASIC, one is called as FPGA. We'll try to understand what is the difference between ASIC and FPGA in few slides later. We are also starting a course on RTL design and integration. The DFT. The DFT demo session, DFT specific demo session will be at 3 p.m. today. It will be the same link. The link you have used to join this session at 3 p.m. Please join the session using the same link. The front end demo session will be from 9:30 a.m. to 12:30 p.m. The DFT demo session will be around, as I said, it will be at 3 p.m. Okay, please sit. Okay. Now you may ask, will, with so many courses starting, will the batches be disturbed? No, every batch will have a dedicated schedule. The only the initial for all these courses, except for this experienced engineers, the initial 1 month training will be common. Whether we start front end domain, please come to the front. Okay, whether we start front end domain, whether we start back end domain, everything has to start with some fundamentals. The fundamentals, I mean, the digital design, the basics of GVIM, some basics of Verilog. So they will be common for everyone. So that 1 month will be common. From the second month onwards, you will be segregated into batches. Those who are taking DFT, their specific topics will start. Those who are taking functional verification, Verilog language training will start. So our admin will give you the detailed schedule for on a weekly basis. But first, let us start off with understanding of electronic system. In the meantime, I mean, while I'm teaching, if you have any questions, please feel free to stop and ask me. So let us start off with understanding electronic system. Now, why understanding this is important is, most of you are from, as a fresh graduates, you are from either BTech or MTech. You probably don't have a in-depth understanding of what is VLSI, what is embedded system, what is software. I mean, you may have some idea, but I want to make sure that you get that idea before we go deep into the VLSI design flow. Okay. So first, let us start off with understanding an electronic system. So tell me an example of electronic system that you see. A mobile phone is an example of electronic system. A laptop, even this device I'm using is an electronic system. Everything around us is electronic systems. Basically, this is not just a piece of hardware. The electronic system is not just a piece of hardware. There are other things that make up the electronic system. I mean, it has got the operating system. I mean, what operating system generally do we have in mobile? Either iOS or Android. Okay, one of them. Other than that, I mean, that is what two things comes to your mind: the hardware and operating system. Other than that, we also have some drivers, what we call as the firmware, which sits between the hardware and the operating system. Okay. Then on top of operating system, what do we have in the mobile phone? What else do we have? Let's say once you purchase the mobile, what will you do on top of mobile? You install various applications, right? Apps. So basically the overall electronic system consists of four different elements, layers. At the basic level, you have the hardware, then you have the firmware, then we have operating system, then we have the applications. That is how every electronic system is designed to be. I mean, there could be simple electronic systems, simple things where you may not require operating system. I mean, in embedded system, if you go, you may come across RTOS, real time OS. There are multiple other aspects. Generalizing any electronic system, there will be always four layers. As a VLSI engineers, can someone tell me what is our responsibility? Are we working at hardware level? Are we working at drivers, that is firmware level, that is also called as embedded systems? Are we working at software level, that is at operating system level? Which layer do you think we are responsible for? As a, we are responsible for development of the hardware. So the embedded system engineer responsibility will be to develop the drivers. So whenever I use the term drivers, firmware, embedded system, all three refers to the same thing. In few minutes, I'll also explain what do we mean by a driver, the term driver. So to understand everything, to understand all this concept, let us take a simple analogy. A bus with passengers. Uh, so in a bus, what all elements are there? Who are all there in a bus? The bus, the driver, the conductor, and the passenger. So there are four things that make up the bus, right? The bus is like the hardware for us. The bus is the hardware, right? Then who is the person who controls the bus? It is the driver, right? It's the driver who controls the bus. So he is the driver in our system. Actually, if I have to write here the hardware, on top of that you have drivers. Okay, let me take here. So hardware, then we have got drivers, then we have got operating system, OS, then you have got the applications. So the VLSI engineer fits here. Means the role of a VLSI engineer is to develop the hardware. Coming back to our analogy, I was taking the analogy of a bus. Now you may ask, I mean, why are we talking about all this? I'm here to attend VLSI front-end training demo. It will be a good idea for us to spend few minutes and understand what is VLSI, what is embedded system. Then let's go deep into hardware. Okay. In a bus, what is there at the basic level? At the here is the bus. Here you have the driver. Here you have the, you can draw similar correlation. In a bus, if you want, as a user, if you want the bus to be stopped, what do you do? Do you go and directly control the bus? Do you go and stop the bus directly? No, right? What will you do? You inform conductor, then conductor informs driver. Even conductor doesn't control the bus directly, then driver controls the bus. So driver has few controls. What is the controls driver has? Let's count: the accelerator, brake, clutch, the handbrake, okay, steering, multiple things he has got control, right? Even in embedded systems, I mean in electronic system, in the electronic systems also, driver is nothing but a, is not a physical entity. Driver is a series of instructions. Series of processor instructions in assembly language. Let's read again. What is meant by a driver? Driver is not a physical entity. It's not any physical entity. The physical entity is only the hardware. On top of hardware, whenever we say the term driver, driver does not refer to any hardware. Driver is a series of assembly language instructions which access the registers in the hardware. Let me again repeat. In my hardware there will be registers. I'll give you a simple example here. In a washing machine, you control the washing machine, right, for different wash modes. When you are turning the knobs, you're actually programming the registers inside the washing machine to set, to do some settings. Here also, the way the driver controls the bus through 5 6 different controls, the driver in embedded system, in electronic system, also controls the hardware by means of register programming. My hardware will consist different registers. By programming those registers, the driver will control how hardware should behave. Coming back to the bus example, see, the driver is able to control everything, right? Driver is able to make sure that the bus goes fast, bus slows down, turns left, turns right, everything he is able to control with the whatever controls that have been given to him. The same way in electronic systems also, first the flow starts with applications. I will invoke one application, okay, let's say WhatsApp, that will get communicate with operating system. Okay. There will be some concept called as API, application level interface calls will be there. Then OS communicates with the driver, the driver communicates with the hardware. So this is how we need to understand electronic system. Now why it is important for us is that your role as a VLSI engineer, whether you get into front end domain or whether you get into back end domain, whichever domain, whenever you say the term VLSI, your work always revolves around hardware. You will not have anything to do with applications, you will not have anything to do with operating system, not even to do with drivers, but you need to have some basic understanding of drivers because it is the immediate layer to you. You are immediately interfacing to the driver, right? So you need to understand what is the role of a driver. I mean, you need to understand how does driver control me, control the hardware. Again, taking the example of a bus, the person who is manufacturing the bus, there, see, you see bus is manufactured by a company, right? Volvo, Tata, Ashok Leyland, different company. Those people need to manufacture the bus in such a way that it is convenient for the driver to use it. Okay, the way they give controls everything. So the same way, when I develop my hardware, when I develop my mobile phone as a VLSI engineer, when I develop a laptop as a VLSI engineer, I should develop the hardware in such a way that it should be convenient for the drivers to work with it. They should be able to easily control the hardware behavior. Okay, it could be switching off the phone, switching on, or switching the different modes, increasing the volume. They should not complicate the usage of hardware. Okay, so that is where, as a VLSI engineer, your responsibility will be to develop hardware. Let me repeat again. Whether you are a front end engineer, whether you are a back end engineer, it could be verification engineer, physical design engineer, DFT engineer, your role is always around the hardware only. Okay. On top of hardware, since you interface with the drivers, you should have a basic understanding of how does drivers work. Okay. That is, you don't need to know anything about OS, you don't need to know anything about application, because It is the drivers who work with OS. So for you, you're only involved in these two things. So with this basic understanding, let us go into the slides and understand little more deep. Let's start with understanding what goes into a mobile phone. This is all, if you open a mobile phone, this is all what you see in the mobile phone. Okay, at the board level, okay, PCB level. It has got various components that make up, like it has got different chips, then it has got different elements, camera module, earphone jack, whatever you see here. For this mobile phone to work, this hardware alone is not sufficient. Let me again repeat. For this mobile phone to work, the hardware alone is not sufficient. You need to have other elements. Can someone tell me what else is required for my mobile phone to work? You need the drivers, which controls the hardware. Then what else do you need? OS, the operating system, which further gives instructions to the driver, which tells which driver should run. Then what else do you need? Applications which work on top of the operating system. That four things put together makes the electronic system. You see what all things make up a mobile phone? It is the hardware. Now hardware could be different chips, the processors, the screen, the USB port. Everything that you see physically is a hardware. I mean, if you see, whatever you see is a hardware only. There are things which we don't see, right? Because do we see a driver code? No, right? Where is it present? Tell me. Inside mobile, where is it present? Somewhere my RAM is there. You see, when you buy a mobile phone, there will be 64 GB mobile or 128 GB. They'll be there, right? Somewhere in those memory, your driver codes is present. When you invoke an application, okay, whenever I invoke an application, what happens is those driver code moves from, it will move from that memory into your DDR memory. Your mobile phone has two types of memories. What are the two types of memories in any? One is the DDR memory. Will DDR be very big in size? It will be how much size generally? 8 GB RAM, 8 GB or 4 GB or sometimes 12 GB. You can see, right? Other than that, what else you have? The other storage you have, which is 64 gigabytes or 128 gigabytes or 256. So all your application, everything is installed where? Is it in DDR or is in that 64 gigabyte memory? It will be in the 64 gigabyte memory. Here comes a concept called as volatile memory, non-volatile memory. Let's not deviate too much because for you it's a little advanced topic. All I wanted to tell you is that inside my mobile there is a memory. Inside that memory, my applications are present, driver code, everything is present. Whenever I start an application, that driver code moves into my DDR and my processor executes those instructions from the DDR. Please come forward. Let me again repeat. Whatever applications you install, WhatsApp, PhonePe, or any other application, they get installed in the 64 gigabyte memory or whichever one. Whenever you invoke the application, that piece of code gets moved to your DDR and processor starts executing those instructions. So, okay, these other things we'll discuss as we go forward. Okay. Next. So there are things which we don't see, like drivers. Please come forward. Then the operating system, then the applications. So if you see mobile phone, how many layers are there totally? 4 layers are there. At the very basic level, you have hardware, that is the processors, camera, and sensors. Who is responsible for developing hardware? It is the VLSI engineer. Rather, we should call hardware engineer. The person who is responsible for developing hardware is hardware engineer. Now, hardware engineer itself has multiple roles. It can be a FPGA engineer. He can be a VLSI engineer. He can be a PCB designer. There are different job roles. If someone is developing hardware as a PCB, he is also a hardware engineer, right? Okay. But since we are talking about VLSI, we'll refer it as VLSI. So what is that I want to emphasize here is that as a VLSI engineer, our role will be to development of hardware. So how does that flow work? I'll explain you in few minutes. What is the second thing that is in the mobile? It is the firmware, right? Or the drivers. Who is responsible for developing the firmware? It is the embedded system engineer. Whether we call embedded system engineer, the firmware engineer, both of them are referring to the same thing. What is the third thing? The operating system. It could be Android, iOS, Windows, Linux, all these things. Who develops OS? It is the software engineer. What is the fourth thing? The applications. It could be the apps in mobile like GPay, Maps, everything, right? Who develops them? It is the either software engineer or there will be app developers will be there. So for an electronic system to work, all these four layers are important. I mean, all these four layers are essential for electronic system to work. Go back to that bus example. Without hardware, without bus, can we have a bus? No, right? That hardware is required. Without a driver, is it possible? No. Again, without conductor. I mean, everyone has an important role, but there are times where these two roles are played by one person only. The driver and conductor can be one single person. Same way, electronic systems can be developed where you have hardware. The OS and drivers are installed as a single unit. That is possible. I mean, when you go a little deep into processors and embedded system, you will understand it. Then you have got the applications. So till now, we have understood what is an electronic system, different things that make up an electronic system. As a VLSI engineer, what is our role? So before we move on to the next topic, that is different styles of VLSI design flow. Do you have any questions? Fine. Uh, Let us get into the next topic, that is VLSI design styles. So what does the term VLSI stand for? Very large scale integration. So when you say integration, what are we integrating? We are integrating transistors, right? What is meant by integration? Let us try to understand. Integrating means what? Putting together. Let's take a simple analogy, the house. So house is integrated using what? Bricks and cement. But very basic unit will be the brick. So using bricks, we are integrating everything. Okay. Same way in VLSI, whenever you manufacture the chips, the chip consists of billions of transistors. Because it is billions in numbers or large numbers, it is called as very large scale. One second. Those attending online, are you facing any issue with my audio?
Yes,
Those is the is it good or is it breaking? My audio is breaking.
sir. It is good.
Okay, thank you. Okay, so we are integrating billions of transistors. That is why it is called as very large scale integration. I will also be explaining the entire flow in detail. Okay, what is meant by front end domain, what is back end domain, little bit about what is physical design, what is DFT, all those things I'll be talking about. So we are integrating transistors. This VLSI flow can be done in two major styles. One is called as ASIC, one is called as FPGA. What does ASIC stand for? Application specific integrated circuits. What does the term application specific means? You have specific application in mind. Let us say I set up a company where I want to manufacture a mobile phone. So when I set up a team, of let's say 50 people who start working on developing of mobile phone chip. That becomes application specific, right? Because the people who the team I have set up, they are only working towards developing a mobile phone and integrated circuit. I mean, putting together all the transistors, everything is what we call as an integrated circuit. So when we work on a development of a design with specific application in mind, it is called as application specific integrated circuit, because once I develop that, it will only work like a mobile phone. It cannot be used as a laptop, it cannot be used as a tablet, because the design is meant to work as a mobile phone. The hardware is developed for specific applications only. Example, mobile phone chip, the laptop chip. What is the second style of VLSI flow? It is FPGA, which stands for field programmable gate array. So the same FPGA board can be programmed to behave like different applications. When I say applications, different electronic devices. Now FPGA board can be programmed to behave like a mobile phone. It can be programmed to behave like a laptop chip. Okay, these kind of things are called as field programmable. Since you are programming it, you are calling it as programmable. What does the term gate array indicate here? Gate array. What is meant by array? Series of elements. Okay, so here gate array would be something like you've got each point is a gate. Each element here is a gate. What is gate we are talking about? The logic gate, the AND gate, OR gate, NOR gate, XOR gate, this thing. Now you can configure it whatever you want, whatever kind of gate you want. You want XOR behavior, you can program it to behave like a XOR gate. You want some other gate, you can program it. So by programming this board as per your requirement, you get the required hardware, which can behave like a mobile phone, laptop, or any other electronic device. Okay, it is not as simple as I said. Of course, my FPGA board has to be complex to support everything, but this is the basic idea behind FPGA board. In ASIC, what happens is everything you start from the scratch. You don't have any board to start with. Whereas in FPGA, where does it start? You already have a board in which series of logic is there. You program this logic to behave like an AND gate, OR gate, XOR gate, whatever gate you want. Like that, every point can be programmed the way you want. So when you program the way you want, you will also get the circuit that is required for you. Now, given this, which one looks better? Do you think ASIC is better or FPGA is better? FPGA is better, right? I mean, what we feel is that FPGA is better because the same board can be programmed to behave like a mobile phone, laptop, or anything else. But as you go deep into these two things, little more, you will understand that industry prefers ASIC. One more level, if you go down, when you understand what is ASIC flow, what is FPGA flow, the cost involved, you will realize that industry, how much is the preference? Around 80 to 90% of companies go with ASIC. Around 10 to 20% of companies go with FPGA. Why is it so? One of the major reasons is the cost. For example, I want to develop a mobile phone using ASIC flow. It may cost me around $15. Just an example, okay? FPGA could cost me $50. The same chip, same behavior, same logic. That is the difference. That could be the difference, okay? It's not always like 15 and 50. Don't literally take it. All I'm trying to tell you is that ASIC is cheaper, FPGA is costly. Okay, because the manufacturing the board itself costs some amount. Whereas in ASIC, we follow a different style because we start from the silicon level. Per chip cost turns out to be cheaper. We start with a silicon wafer. We manufacture chips here. Each thing you see is a chip. One chip, another chip, another chip, like that. Okay. Because we manufacture everything in bulk, when you manufacture in bulk, what happens is the per chip cost will be cheaper. So even though you see FPGA has one advantage where the board can be used to behave like different circuits, different kind of applications, still industry prefers ASIC. Whether you take Qualcomm, whether you take Intel, Nvidia, Broadcom, majority of these companies and majority of the teams in their companies will be working on ASIC. Okay. Let's say you go to Cisco, they may have FPGA team. Okay, we'll discuss where do companies prefer FPGA. We'll also discuss which companies prefer ASIC flow. But final, what is the baseline? Whether you follow ASIC or FPGA, in both the ways, you can develop the chip. So there are two styles in which the chips can be developed majorly. One is ASIC style, one is FPGA style. So let us try to understand what is the difference between ASIC and FPGA in terms of the cost, in terms of the process also. As I said, though it looks like FPGA approach is better, industry prefers ASIC design flow due to lower cost of manufacturing. So manufacturing cost will be less. Like it's typical our mentality, right? I mean, as a consumer, you want to buy a mobile phone. One says 15,000 rupees, one says 50,000 rupees. Both have same functionality, same features. Which one will you buy? This one, right? Same thing companies also does. For them, how do I reduce the overall cost of manufacturing? So it is ASIC is where they are able to manufacture the same chip at a lower cost. Then the next question comes, then everyone should be using ASIC only, right? Why to go with FPGA? If your requirement is only limited in number, let's say I want to manufacture only 1,000 chips. My requirement itself is only to manufacture 1,000 chips. Then I'll go with FPGA. For limited applications, limited requirements, I go with FPGA. For bulk manufacturing, mobile phone, is it limited or bulk? Bulk. Why is it bulk? Because it sells in millions of mobile phones. Not only in India, across the world, it sells in millions, right? So because of that, whenever something is manufactured in bulk, they will always go with ASIC. Whenever something is manufactured in limited requirements, okay, something example could be a hardware that goes into a flight, aeroplane, right? Do you think everyone at every house uses that hardware? Only it is used in the aeroplane only, right? In those cases, is it bulk manufacturing or limited manufacturing? Limited. In those cases, though, they go with FPGA. For them, that is cheaper actually. For them, FPGA will be cheaper. So we will try to understand how does this difference is coming into picture. So here, let us try to understand the difference. So why is that we are talking about these two things is that I want you to understand that there are two types of job roles mainly also. One is ASIC job role, one is FPGA job role. You can also make your career in FPGA as a FPGA system design engineer. Okay. You can of course get into ASIC also. So first, let us start off with understanding the ASIC design flow in terms of the cost. In ASIC design flow, the initial cost will be very high because you don't have anything to start with. We don't have anything to start with. We need to set up the flow from scratch. Okay, you need a bigger team. You need to purchase a lot of applications, softwares, and everything. That will cost multiple $1 million. It will be a lot of investment will be required in the beginning. But once you have set up, once the flow is working, once the flow is set up, per chip manufacturing cost will be less. So the initial investment will be high, but per chip manufacturing will be cheaper. Whereas in FPGA, the initial investment will be less. Why is it less? Hardware is readily available. For you, the hardware is readily available. So you don't have to manufacture the hardware, you just have to purchase it. Okay, you just have to program it. Whereas per chip cost will be more. I mean, board will cost you more. So given that, the equation will come something like this. I think this is not the right PPT. Okay, that's fine. Okay. So this is not a right curve. It should be like this actually. Yeah, please come. Please come forward. So initial cost of ASIC will be high. See this, if you see this diagram, the x-axis is the number of units manufactured. The x-axis is the number of units that is manufactured. Y-axis is the total cost. Let's say I want to manufacture 1000 units. At 1000, if I draw a vertical line, it will tell how much does FPGA cost, how much does ASIC cost. Okay. So in FPGA, generally your initial investment will be less, whereas in ASIC, initial investment will be more. Because of that, whereas you see FPGA curve is very steep. FPGA curve is very steep. ASIC curve is like this. It means that there is this point where the cutoff will happen. Till this point, let's say this number is 10,000. This number is 10,000. If you want to manufacture anything less than 10,000 units, FPGA is a better option, because anywhere if I draw a line here, which one is costing me less? FPGA, right? Because FPGA cost is this much, ASIC cost is this much. Which one is smaller? FPGA. Whereas if I draw a line here, which one is costly? I mean, which one is costing more, ASIC or FPGA? It is FPGA which is costing more. Beyond this point, FPGA will cost more. Before that point, FPGA will be cheap. So this is how companies make the decision. I mean, they make a decision based on, it's not only the factor, there are other factors also, which will be taken into the account. Just give me 1 minute. I have to open the right presentation. Yeah.
In ASIC, like whatever we design,
Yeah.
that same program, like same functionality, we can do through FPGA also.
We can do that, yes.
But the size may be high. Like
Size could be higher. We'll discuss all those differences as well. Okay. So you see here, the ASIC initial cost will be higher, FPGA initial cost will be lower. But you see this curve is more slant. Means what? You see it per chip cost will be higher because it's more slant. Whereas in ASIC, it is very flat. The only your initial investment is what is very high. But once you do that, your per chip cost will be less. As I said earlier, for this range, FPGA is better. Anything beyond that, ASIC is better. Let us try to understand ASIC versus FPGA. Any VLSI chip can be developed either in ASIC or FPGA flow. Decision is based on overall cost. Okay, as I said earlier, in simple term, in summary, the companies which want to manufacture for bulk usage, they go with ASIC. Limited application usage, FPGA. So in general, around 80 to 80% of the companies work in ASIC. Around 15 to 20% of the companies work in FPGA. For example, you have Boeing, Airbus. Let's say they are developing their hardware. So which style they will use? they'll use FPGA. If you go to their companies, you will see FPGA style of development. Let's say you go to Qualcomm, a team which is working on mobile phone chips. There you will see ASIC flow. Let's say you go to Cisco, they are working on routers. They may use, mostly they'll use ASIC flow only because the routers are also implemented for bulk usage purpose. Let's say there is a company which is set up for defense applications. Let's say some defense flights or anything, there will be different applications, right? Which technology will they use, ASIC or FPGA? FPGA, because even there for defense, it will be limited manufacturing, right? So let's try to understand advantages of ASIC over FPGA, because both of them has their own advantage. Both are there. I mean, let's say if ASIC only has all advantages, then there won't be any FPGA, right? If ASIC has every advantage, then there won't be any FPGA at all. So first advantage of ASIC is it is cheaper. Per chip cost will be less. It consumes less die area. The area will be smaller, hence it is cheaper also. It provides flexibility to customize the design features. What does it mean? Since you are starting from scratch, you can customize the chip as per your requirements. Whereas when you use FPGA board, you have to implement the design in line with the FPGA board requirements, right? I mean, you at one point the board becomes your limitation. The board capability becomes your limitation, right? Because you cannot do more than what board can provide you. It will be power efficient because you are developing from scratch. The ASIC will be power efficient, and most importantly, ASIC can work at higher frequencies compared to FPGA, hence they give better performance. Okay, so when I say, let's say Qualcomm is choosing ASIC, it is not only because of the cost. These are the other factors which drives them. Okay, there are many factors that they choose, because of which they are going for ASIC flow. Now, similar to this, FPGA also has advantages over ASIC. Okay. First of all, did everyone understood what is ASIC, what is FPGA? Okay, it is like when I want to manufacture a mobile phone or any electronic hardware, there are two styles in which we can approach. One is called as ASIC style, one is called as FPGA. In both the cases, your final product will be mobile phone only. But we are here trying to understand how do they differ, what is the advantage of ASIC over FPGA, and what is the advantage of FPGA over ASIC. Let us talk about the second aspect. What are the advantages of FPGA over ASIC? Tell me, what is the first advantage? Okay, first thing is your what is that? If there is a bug, I mean, let me put it here. If the chip has a bug, let's say you have manufactured some aeroplane application, you have manufactured also. You figured out that there is a bug, that hardware is not working properly, which is detected after manufacturing. FPGA style won't incur big cost, because in FPGA you just have to throw that board, take a new board, implement the updated logic. Let me again repeat. In FPGA, you have purchased a board, you have programmed the board for your requirement. While using that board, you figured that there is some bug in that. Bug means what? Something is not working properly. Your cost is only the cost of this board. Okay. Then what can you do? You purchase a new board. Whatever is the problem, you fix it, put it, it will work. Whereas in ASIC, we have to go through the entire process again. Okay, in ASIC, we have to go through the entire process again, which will itself involve a lot of money. So we don't have to implement the entire flow again. See, bug can be fixed in the another FPGA board. We don't need to start everything from the scratch. Whereas in ASIC, if there is a bug, we need to do the entire flow again, because the people who work on the flow, they'll have to fix the bug, they'll have to do physical design again, the DFD again, the static timing analysis again. The entire flow needs to be done again. Because of that, the overall cost goes up, the time and everything goes up. Second advantage is the time to market. I mean, you can quickly come out with the product because you already have the board. You just have to program the board. Two things, right? One, you are developing from scratch. One, you are using an existing board. Which one will be quicker? The where you are using board. So the flow will be quicker. Okay. Since we don't start from scratch, the board is readily available. Okay. It takes less time to develop FPGA compared to an ASIC. In fact, even in ASIC flow also, people use FPGA. That is called as FPGA prototyping. Even in ASIC, companies use something called as FPGA prototyping. What is meant by FPGA prototyping is, let us say I am developing some electronic application. Okay, let's say it could be mobile phone. Instead of actually manufacturing the mobile phone through ASIC, what I will do is I will use some boards like emulators or FPGA boards. For example, I will test my logic. Is my FPGA, is this logic working fine on FPGA board? Whatever logic I developed, whatever logic I have developed, is it working fine on FPGA board? If it is working fine, then I will go ahead with the ASIC flow. So FPGA prototyping is used. That concept is called as FPGA prototyping. Whatever logic you have, implement as an FPGA first. Check whether that FPGA is working fine. If it works fine, then go ahead with the ASIC flow. Go ahead with ASIC manufacturing. Because you have proved that, right? In FPGA board, if it is working, it will also work in the ASIC board. So FPGA prototyping is used to check ASIC behavior before it is manufactured. What is meant by FPGA prototyping? Implementing ASIC logic on the FPGA board and check the behavior. We can figure out any issues in the design before going for ASIC bulk production. Okay, the same concept, similar concept is called as emulation. Okay, where you have got a very complex boards on which we put the logic and check the boards. We have discussed the cost factor, everything. Let us try to now understand how does the VLSI design flow differs between ASIC and FPGA. How does it differ? Let's try to understand. The front-end domain flow is similar for both ASIC and FPGA. I told you, right? VLSI has how many major divisions? One is called as front-end domain, one is called as back-end domain. So front-end domain is about understanding the design requirements, implementing the Verilog code, and verifying that code. Three things are there: understanding the design requirements, implement the behavior using Verilog code, and do the functional verification of that code, whether that code is developed properly. Whether you take ASIC, whether you take FPGA, that flow will be similar between both of them. Between ASIC and FPGA, the front-end domain flow will be similar, because in both the cases you need to develop Verilog code and verify it. So then where do they differ, ASIC and FPGA? They differ in the back-end domain flow. So in both the cases, user needs to understand the design specification, implement the design using Verilog or VHDL languages, and functional verification of the design behavior using system Verilog and UVM. So then where do they differ? Majorly they differ in the backend flow. The flow starting from physical design to custom layout. The way we do floor plan, placement, the power plan, the CTS, routing, IR drop analysis, they are completely different in these two domains. Because in FPGA, you don't have flexibility. You have to plan your chip as per the FPGA board. See what I'm telling? I think let me just give you a basic idea about what is floor planning and everything. Okay, what is this term floor plan placement? All this is basically let's try to understand the some basics of physical design flow. Okay, I told you that VLSI has two domains majorly. First one is front end domain, second one is back end domain. In front end domain, we develop the behavior design behavior using Verilog code. That Verilog code is functionally verified. Now, when you want to buy a mobile phone, do you buy a Verilog code? No, right? The shop person will sell you the physical hardware. The flow starting from the Verilog code till the chip gets manufactured. This entire flow is called as VLSI backend. Let me again repeat. The flow starting from the Verilog code till the chip gets manufactured. That entire steps is called as VLSI backend. It starts with the important step called as this is the transition point. See, I told you this is front end domain, back end domain. The middle point where they transition is called as synthesis, where you are moving from front end to back end domain. What is synthesis is there is a tools, synthesis tools. What is their specialty is give them Verilog code as an input.
ఇప్పుడు 25 గమ్మున ఉందని అనుకుంటే
Verilog
నాకు
code
బడి
which is
రిపేర్
written
అంటాడు
more like an English. You would have written always do this, if this condition do this kind of code. It's more like English. Whatever code you have done is more like English. This synthesis tool, what is this tool I'm talking about? The synthesis tool, they will generate logic gates. Whatever your Verilog code is there, it will convert and give you in terms of logic gates. What logic gates? The AND gate, OR gate, XOR gate, NAND gate, NOR gate. In terms of that, it will give you. So you see, it's a very important point in the flow where you are transitioning from your Verilog code to logic gates. From these points, the backend domain starts. This logic gates, what you get, what is output of it is basically macros plus. When you do the synthesis, what is the outcome of synthesis? You get macros and logic gates. Macros is nothing but the different blocks. Okay, for few minutes we'll deviate a little bit from the front end domain. Okay, here, so what are we trying to understand? We are trying to understand the difference between ASIC and FPGA. So in ASIC, what happens is, if you have this as a die area, these macros will be something like this, blocks. So the role of a physical design engineer is to place these blocks into this die area, and even standard cells. Let's say standard cells I represent in a red color. He arranges everything, okay, then does the connections. Here comes the difference between ASIC and FPGA. In ASIC, you don't have any board to start. You're just starting with an empty plain area, you can now start deciding, I'll place this block here. Sorry, I'll start place. You can say I'll place my block here, another block here. In FPGA, you don't have such flexibility because the board is already available. You have to plan your physical design as per the board. Whereas in ASIC, because everything is empty, nothing is available, you start planning. So where do you think we can efficiently do floor planning? In ASIC you can do, because in ASIC you can arrange the things in a more efficient manner. Okay. So that is where the difference will start, and the entire backend domain will differ between ASIC and FPGA. I hope you got the basic idea between what is ASIC, what is FPGA.
Sir, what is the difference between macros and standard cells?
Macros means, see, if I take any chip, I'll explain through a chip. If I open this kind of thing, probably it's not clearly visible. Each block here becomes one macro. Okay, let's say one processor is there, it's a macro. One GPU is there, graphics processing unit, that is a macro. Okay, USB controller is there, it's a macro. When you are manufacturing everything, there will also be some additionally standard cells, that is logic gates manufactured. So every block is a macro. Other than that, the other connecting logic is called as standard cells. This is the overall circuit. If some of you are not following the term what is macro, what is floor plan, what is power planning, please don't get confused with all those things. Okay, because as we progress, whatever is relevant for you will cover each and everything. So coming back to this flow difference, majorly ASIC and FPGA differ where? In the backend flow. That is the flow starting from physical design to custom layout. All these steps will differ. Okay, let's spend another 10 minutes before we go for break and try to understand the ASIC design flow. Because I was anyway talking about floor plan and physical design, so let me complete this and go for a break. Let us first talk about ASIC design flow. Okay, so let us start off with taking a simple analogy. I keep taking analogies, not only me, my other trainers. Whenever we do the course, we will take simple analogies so that you can easily correlate with the topic we are discussing about. So in this case, to understand ASIC flow, we will take an example of a house construction. So where does the house construction start with? Do you directly start with putting the foundation and everything? No. First you have to plan. Where does it start? You sit at home and you list down your requirements. First you list down your requirements. Then whom do you go to? You go to an architect or engineer. He gives you the plan. Then you go to a contractor. There are different steps you follow. Okay, in the house construction, majorly you can divide that entire flow into two categories. One is till the time you have constructed the house, basic structure. Then after the structure, everything you do. For example, the painting, the tiles, okay, electrician work, plumbing, everything is the second part. Same way in VLSI also, whatever we do can be divided into two parts. One is front end domain, one is the back end. Okay. So first, house construction starts with what? Requirements. Like what kind of house do we need? Then whom do you go to? Architect. So for him, what is the input? Your requirements. What do you need from the house? These are your requirements. Then what is the output? He gives you architecture diagram and various plans like plinth, electric, plumbing, everything. He gives you the plan. When you go to the contractor, this becomes his input. So the output of previous stage is input to the next stage. So output of previous stage becomes input to the current stage. Let's say now we want to give some inputs to the contractor. What do you tell? You won't tell what kind of house, you just give him these plans. So for him, inputs are those things. Then output will be what? Building structure. He will finally construct the building and give you. So once it is done, you go through different stages, right? I don't want to explain the house construction flow. All I'm trying to tell here is that in the house construction flow, your final goal is to have a house which is done as per your requirements. In the VLSI design flow, your requirement is to manufacture a chip which works as per your requirement without any issues. Is this house construction done by only one person? No, right? If you see, there are almost 10 to 15 categories of people involved. Okay, the person who works as a laborer, can he do carpentry work? Someone who is a carpenter, can he do plumbing work? No, right? That means even in house construction, everyone has their own specialization. Even in house construction, every worker has their own specialization. Okay, same way in electronic flow also, in VLSI design flow also, a physical design engineer has his own specializations, skill set. A verification engineer has his own skill set. DFT engineer has his own skill set, which some other engineer cannot do. Someone else cannot come and do DFT work because they develop that skill set over the years, and that skill set is what they use. So in simple terms, if you understand the house construction flow, you can easily correlate with ASIC design flow. In fact, they have a lot of very skill set. I mean, electrician has very important skill set. A plumber has a very important skill set, which you and me cannot do. The only problem I see there is they didn't put the effort at the right time. That's where they end up doing that work. Let me again repeat. The people who work as electrician, they don't earn as much as a software engineer earns, or as much as hardware engineer earns. Where they missed probably is they didn't put the effort at the right time. Because I see many plumbers, electricians who are much more skilled. It's just that they probably didn't plan. So what I'm trying to tell here is that earlier you put the effort, better will be your career. The same effort you put after 10 years, you won't get the same outcome out of it. Let's now talk about ASIC design flow. So ASIC design flow consists of around 15 steps, divided into two major categories. What is that? Front end domain, back end domain. Let us talk about those steps. First one is the front end domain. Next is the back end domain. At the end of this discussion, you should have an idea about what is VLSI design flow. So the VLSI design flow is about what? Finally, manufacturing a chip, working chip. That is the final goal. But one person cannot do that. Like one person cannot construct a house. So there is a series of steps and series of people involved. That whole flow is divided into two major steps. One is front end domain, one is back end domain. The front end domain starts with what? Requirements. The same as in house construction. What is the next step? Architecture. Here also exactly the same thing. Then RTL design, then RTL integration, then RTL functional verification. What is the term RTL refers here? It refers to register transfer level. Okay, those who are new to it, don't get confused by that. It's a one style of Verilog coding. The term RTL stands for register transfer level. It is one style of coding in Verilog. It's a simple thing. The term looks complex, but when we go into Verilog, we'll see that it's easy. So one we are developing, one we are integrating, next stage we are verifying. So the most of you who are looking for verification course, right? You say ASIC verification, you say functional verification, you say design and verification. We are talking about this. The next step will be DFT, design for testability, that is done at the Verilog RTLF. So with this, we complete the front end domain flow. What is the next step? The back end domain. Back end domain starts with what? Synthesis. I have already explained you what is synthesis, right? What is synthesis? You have a tools. Okay, these are called as synthesis tools, design compiler, genus. There are some tools which you can purchase from Synopsys and Cadence. When you give this RTL code as an input, what do they give as output? Logic gates. Logic gates means your same functionality in terms of AND gate, OR gate, XOR gate. So from there you start. Again, you do DFT at the gate level. What is DFT also? I'll explain you briefly. Then we do physical design. In simple terms, what is meant by physical design? I'll give you a simple analogy. Let's say I have this table where I'm keeping what all things are there on my laptop. My table. Laptop is there, some audio device is there, mobile phone is there, some charger is there, different elements. How do I plan my table area to arrange everything properly? Okay, let's say this device is there. Okay, shall I keep it in the back? No, right? Why? Because if more close I keep, better will be the audio quality. So I plan there will be some rules that I need to follow. I means who? The physical design engineer. He's trying to, right now, how many elements are there in my laptop on my table? 5 elements are there, which I will plan. Laptop will be placed here. Okay, my microphone device will be placed here. Okay, my charger will be placed here. The way I am planning. Okay, in physical design, when you go to physical design, majorly the physical design engineer deals with the two kinds of elements. What are the two elements we discussed? Macros, standard cells. He has got hundreds of macros, millions or billions of standard cells. Okay, so in simple terms, what is, then you may say, what is so complex about it? I could arrange everything in 2 minutes here, right? Laptop here, my audio device here, mobile phone here. What is complex for physical design engineer is in a small area. How small is this area? 1 centimeter. 1 centimeter, he has to place billions of transistors. I mean, he has to arrange many macros, some hundreds or thousands of macros, okay, in such a way that everything is connected properly. It's not just placing. See, did I just place it? I took all the connections also. You see, to my laptop, I got the LAN cable connection, the HDMI connection, my USB connection, power cable connection. There, they have to do thousands of electrical connections. Every block has to get a reset logic. Every flip-flop has to get a clock. Okay, so the whole concept of physical design is gets complicated there, because they have to place hundreds or thousands of macros, the blocks, and lot of standard cells, and for all of them they have to do the connections, which makes it complex. So that is where the entire backend flow is driven by softwares. The physical design engineer does not do everything. The physical design engineer does not do everything. He takes the help of softwares. What is an example of software? I'll give you. You go to mechanical engineering, there is a courses called as ARCAD, computer aided designing, right? What do? They use the CAD tool to to develop their designs, right? The same similar kind of things. Here, the physical design engineer doesn't do everything here. He takes the help of software to place, where to place, how to place. The tool itself gives the suggestion, you can place here. This is the style you can follow. Then the physical design engineer comes into picture. Intelligence comes into picture. That is physical design. Very briefly, okay, very briefly I have explained. Physical design is all about planning your physical area. You have the chip, where to place what, how to connect them, and while making sure that everything still works. While doing that, they do something called as static timing analysis. If static timing analysis is not done properly, the electronic device won't work. I mean, you cannot even open this because it will go into a unstable state. Once it is done, the next step is called as custom layout. The next will be physical verification. What is physical verification? Is checking different rules. I'll give you a simple example for physical verification. You see outside the house in the road, you will see the electrical wires going, right? The transmission wires. How much do you see? They will keep some minimum gap between the wires. Can they place very close with only 1 inch apart? How much gap do they maintain? If you see generally minimum 1 feet, you will see. Those kind of rules they have to follow. Even inside the chip, if you open the chip, actually lot of copper wires will be there. There also they have to follow some rules called as DRC rules, design rule checks, okay, layout versus schematic checks, antenna checks. Some checks will be there. Let's not get into all those checks. In simple terms, they have to check whether all that whatever implementation is done, is it done with some rules. That checking is called as physical verification. It's like someone coming and checking, inspecting, is the connections are done properly, is the minimum spacing is maintained between one transmission wire and other so the physical design engineer, sorry, physical verification engineer checks the similar kind of rules inside the chip. That is called as physical verification. Then finally, once everything is done, you get a file called as GDS2. This file is given for fabrication. Finally, the post silicon validation. Let me explain this term. Okay. What is GDS2? Okay. We'll take a break once this is done. I'll give you a simple analogy for GDS2. Let's say you want to watch a movie. What is the format of file that you generally get? MP4, right? Okay. What you see is a MP4. But before that MP4 became, it went through so many steps, right? The screenplay, direction, so many things that went into the movie. Finally, you are getting it as one single file called as MP4. Same way, whatever these people did, they will generate that whole work into one format called as GDS2. Like in the movie making, they went through different steps, right? Finally, their outcome is what? One MP4 file, which you play. Same way, whatever we are doing here, to manufacture it, they convert into one format called as GDS2 file, which stands for Graphic Design System file. That file is given for fabrication. Okay. Once the fabrication is done, you will get individual chips. We need to verify those chips, whether those chips are working fine or not. I mean, each chip we need to verify because there can be some manufacturing defects inside the chip. When you manufacture, you are manufacturing at 5 nanometer level, which is very, very small. There can be some manufacturing defects. The idea of figuring out those defects is called as post silicon validation. Then finally, once chip is good, it goes for packaging, and finally you have the mobile. Finally you have the working electronic device. So at each stage they do verification. At every stage we keep doing the verification. We check whether everything is working fine at each stage. Only once it is checked, it comes out. Why is it important to do the verification? Because if something is wrong, let's say once you purchase a mobile, something is wrong, you cannot do anything about it. You have to throw off this and buy a new one. I mean, they have to go with the entire flow again. That is why at every stage they keep doing verifications to make sure that nothing is going wrong at any stage. So let us go for a break now. Okay, we will meet in 15 minutes exactly. that is around 11:18 we will meet. 11:03 is now. 11:18 we'll meet, and once we meet, we'll continue with the VLSI design front-end domain flow. We'll talk more about the course structure. More importantly, we'll talk about what is functional verification, what is DFT. Then I'll take up question and answers. Okay. So let's meet at 11:18.
This conference will now be recorded.
So let us resume the session. Let us start with the revision of what we have discussed in the first half of the session. So what is the first thing that we discussed about? We started off with understanding different layers in electronic system. That could be the hardware layer, the embedded systems, the operating system, and the applications. We understood what is the role of a VLSI engineer in this. Then we understood VLSI design styles, that is the ASIC and FPGA, how do they differ? Then what is the other thing we discussed? ASIC design flow. We understood that the ASIC design flow is basically two major categories, two major steps. One is the front end domain, one is the back end domain. If you look at this thing, based on what we have discussed so far, it is mostly revolves around RTL, that is Verilog coding. So the front end domain is more coding oriented job where you need to have the programming skills. Whereas when you come to back end domain, programming is not at all involved there. The coding is not at all involved there. It is more tool and technology. Like I gave an example of arcade, right? Someone who is doing arcade in mechanical engineering, what should be the skill set for him? He should know how to use the tool, different features of the tool. He should be more comfortable with the those the CAD tool and the options and how to use it to implement the designs. Same way, the backend domain in VLSI is tool oriented and also technology oriented. I mean, the people who work into backend domain should have understanding of what is semiconductors, how the fabrication works, the timing concepts, the setup time, the hold time, those kind of concepts. The job revolves around those things. There is no programming skill set required at all there because it is tool and technology oriented job. Now, going by the job requirements, what I see is people getting more opportunities in the front end domain. Even not only here, across the other institutes and the industry. For last 6 months, 1 year, I see more placements happening in the front end domain, more specifically into functional verification. That is the domain for which we are doing the demo session. Now, let us talk about the VLSI front end domain related topics specifics. See, VLSI front end domain work will be similar to a software job role. In software job, what do they do? What is their skill set? C, C++, Java kind of languages they need to learn. They should be good at reading the software specification. I mean, what is the requirement of a software and implement that, develop that using an algorithm and implement the same using C, C++ kind of languages. Understand the software, come up with an algorithm, implement that using this language. That is what a software engineer does. They should be having good programming skills. The VLSI front-end domain engineer role is similar to a software. I'm not telling same. Okay, their role is similar. Like they learn C, C++, Java. Here we learn Verilog, System Verilog, UV. They're very closely related actually, because when you move to Verilog to when you move from C to C++, what is the difference? C++ is object oriented, right? Oops. Even when you move from Verilog to System Verilog is also object oriented programming language. What is the relation between C++ and Java? Java is like a framework on top of C++. Here also same thing. UVM is built on top of system. Now, does it mean that you should have understanding of these languages before you join this course? Absolutely no. If you know that, it's a good thing. If someone is very good with C++, it makes this course very easy for them. Even if you don't know, we'll teach everything from the basics. Even if you don't know basics of C language also, we'll teach from the basics. Only thing that you require is you should have confidence on yourself that I can learn. That's the only attitude. I mean, that's the only expectation, that you should have confidence on your skill set, your abilities to learn the things. The VLSI front-end domain engineer should be good with programming or should have inclination towards programming. Like the way software engineer reads the software specifications, here you read the hardware specifications and understand the design functionality and implement these requirements using different protocols. Like in software they use algorithms, here we use protocols, and the protocols are like USB protocol, the PCI Express, the DDR, AMBA protocols, SPI, various things. So what is that I'm trying to correlate here is the way software engineer works with languages, the specifications and the algorithms. Here we work with these languages, the hardware specifications and the protocols. Let me again repeat. Okay, there is no expectation that you should be good with C programming, you should be good with C++, no expectation at all. We start everything from the basics. When we start Verilog language, we take an example of a multiplexer. What are the inputs of multiplexer? What is the selection line? What is the output? How do you write a Verilog code? How do you develop test bench? Then let's say we take full adder, half adder, comparator. Like that, at that level we start. Then we'll move on to what is D flip-flop, what is toggle flip-flop, how to write a Verilog code for that. What is the change we are doing? We are moving from combinational circuit to simple sequential. So when you move to sequential, what will come? Clock will come, reset will come. So there we'll introduce what is a clock, what is a reset. So how to implement circuits with clock and reset, how to verify them. Once combinational things are done, basic sequential things are done, then we'll move on to the next stage. What is that next stage? Circuits which involve combinational and sequential, little more complex circuits. So we will increase the complexity in a gradual basis. We cannot only teach simple things, because it will not be relevant for the industry. That is what is the problem you face in the colleges. In colleges, most of the things you teach is the basic things which doesn't fit into the industry requirements. Now, where does VLSI differ from software? In software there is no backend flow actually. In software, what do? Once they develop the software, that is directly installed onto the in the hardware and used. Let's say banking application is there, you go to a bank, you see they're using an application right there to manage deposits, withdrawals, everything. That application was developed by a software engineer. They don't need to manufacture that software, they just have to sell the software, people will install and use it. So what is backend flow? I already explained. The process of converting the Verilog RTL code into a chip is what we call as backend domain flow. In software, the code is installed and used. No need to manufacture as a chip. In VLSI, the functional verification plays a very important role. You see, if there is a bug in the chip, the entire flow needs to be done again. let's say in my mobile, if I find some kind of bug, the entire flow starting from the RTL coding we need to do again. Whereas in software, if there is a bug, they don't have to do everything. They just have to fix the whatever is the issue. I mean, you don't lose entire money invested on the flow, setting up the flow. In basically in a hardware, you cannot fix the bug. Whereas in a software, you can fix the bug. Hence, in you see, in talking about software, if there is a bug, it can be fixed easily, can be released as a new version of the software. Whereas in VLSI, if there is a bug, it can't be fixed. You have to work on the entire flow again. That is where the one role called as functional verification is a very important flow in the step. Okay. Let me repeat again. Whatever the test engineer, the tester does in a software, similar thing is what is done in the functional verification in VLSI, but this plays more important. The functional verification plays more importance. Why is it so? Because if at all there is a bug in the design in my chip, you cannot fix it. You have to go for the entire flow again. Whereas in software, even if at all you missed a bug, it can be fixed, released as a new version of the software. So the cost is not very high. I mean, in a chip, if you make a bug, you're talking about some millions of dollars of loss. In a chip, if there is a bug, even if you miss one bug, we are talking about millions of dollars of loss. Whereas in a software, there is a loss. I'm not telling that there is no loss, but it's not as costly as the hardware. Let us now talk about different job roles in the VLSI. So far we have understood what is VLSI, what is front end domain, what is back end domain. Before we go to the job roles, let me give you a brief about DFT. Okay, because we have been trying to understand. I mean, I said that today there will be demo about DFT also. Let me give you a brief about what is DFT. DFT stands for, maybe I may have it. DFT stands for design for testability. You see, in the ASIC flow, I told you that we go for fabrication. Tell me, at what is the current technology where the fabrication is being done? 3 nanometers. Means the transistor channel length, the FinFET channel length is 3 nanometer. What is the channel length? The distance between the drain and the source. In a transistor, you know that there are minimum 4 elements: the gate, the drain, source, and the substrate. The distance between the drain and source is called as channel length. We create a channel between drain and source to turn on the transistor. When the channel is not there, the transistor is turned off. Basically, transistor acts like a switch. Either it is on, either it is off. Okay, so the distance between drain and source is the thing we are talking about as the technology node. So at this level, you can imagine what is 3 nanometer, right? You take 1 meter and you divide it into 10 to the power of 9 parts. There you get the uh, nanometer level, right? So at that level, when you manufacture, there can be manufacturing defects. Those manufacturing defects are called as, they're used for detecting manufacturing, like at speed faults, at zero fault. So in when you manufacture a chip, there can be different types of defects in the chip. What are the some of them? At speed faults, stuck at zero, stuck at one fault. Okay, what is the name stuck at zero means? Some logic is some pin is already stuck, always stuck at zero logic only. Okay, for some reason it got tied. So when it is tied, it will never work because even if you drive logic one, it will never go to logic one. So these are all called as manufacturing defects. The role of a DFT engineer is that DFT engineer uses some techniques called as scan, ATPG, automatic test pattern generation, built-in self-test, okay, JTAG, boundary scan, different types of techniques to generate. Using these techniques, what is his final goal? Generate some test vectors, also called as patterns. What is the role of a DFT engineer? He generates some test vectors. These test vectors are when applied to the chip, the output of the chip will tell whether that chip is functioning properly or has it a fault. Let me again repeat. The DFT engineer uses some techniques. These are called as DFT techniques. The scan, ATPG, which stands for automatic pattern test pattern generation. Third is built-in self-test. Then JTAG, boundary scan, like that some another 3-4 techniques are there. Using that, they generate some test vectors. Now, how does test vectors look like? Let me show you. A long series of ones and zeros. Okay. This pattern is called as test vectors. These test vectors is driven into the chip. This test vector is driven into the chip. The outcome, the output you get will tell whether this chip is good, this chip has faults. The person who does this process is called as post silicon validation. Understand? PSV stands for what? Post silicon validation. The person who generates this is called as DFT engineer. Understand again? The DFT engineer is responsible for developing these patterns. Is responsible for what? Developing this pattern. What is the responsibility of a post silicon validation engineer? Take those patterns, apply to the chip, check whether the chip is working fine or not. So there are two people involved here. The DFT engineer, he uses these techniques to generate this. Okay. So as a DFT engineer, you will be understanding what is meant by scan, how to implement scan using the specific tool, what is meant by automatic test pattern generation, how to implement that. So you will be learning these techniques. So in DFT, you don't need to know any semiconductors. You won't work at MOSFET level. You don't work at transistor level. So given that, you don't need to go down to the semiconductor and technology level. Then what is the final goal of a DFT engineer? He generates many such patterns. Okay, it's not one pattern. Idea is when these patterns are applied to the chip, anywhere there is a fault, anywhere in the chip, we should be able to identify that. Okay. So one pattern is not sufficient. They will use different techniques. In fact, in DFT, we keep a testing logic inside the chip itself. Inside the chip itself, testing logic is kept. In my mobile phone, if the BIST is implemented, inside my chip itself, some self-testing logic will be there, which tests itself. Okay. All those concepts put together is what we call as the DFT techniques. Okay.
Like DFT engineer work with validation engineer.
No. His only role is to give the vectors. Once he gives vectors,
He make patterns and all. The validation engineer
he executes and checks whether the chip is working fine.
So that means DFT engineer works after the chip is manufactured.
No. DFT engineer works before that only, right? Because his work is not at the chip level. His work is at the coding level only.
So like he helped DB engineer also. DFE.
No. He gets the input. See, where does he come into picture? DFT is done at the RTL level also.
So that means like RTL level, like DB engineer works at.
Yeah, after DV engineer, he gives the working RTL code. For that, DFT engineer develops scan logic. Then that is synthesized. Once it is synthesized, the DFT engineer inserts his own logic into that. Then that goes to physical design engineer. Like what is meant by inserting? Change the normal logic to scan logic. Add some BIST logic. Is all done into the DFT. Once it is done, the physical design engineer works on that updated logic. Okay. So again, if you didn't really understood in depth of what is DFT, you can get more details during the DFT demo session. So just to summarize, the DFT is about, see, once the chip is manufactured, let's say this is the chip. All the logic is inside the chip. I'll give you one simple example. Laptop is there. I don't know whether laptop is working fine or not. Somewhere inside the laptop, issue is there. Can I just see the laptop and tell what is the issue? No, right? Inside the laptop, there is something is broken, some issue is there. How do I know that? So what I'm doing is, instead of opening the laptop, because the chip you cannot open, whatever chip you have, you cannot cut it and open and see what is the problem. What you do rather is you apply some patterns to that. The output will tell whether the chip is good, chip is bad. The role of a DFT engineer used to use these techniques, scan, ATPG kind of techniques, to generate this pattern which will be applied to the chip. So any questions so far on this? Okay. Now, with this understanding, let us talk about the different job roles in VLSI. You know that there are two domains, front end domain, back end domain. The team which works on requirements is the marketing team. The person who works on architect is the chip architect. Person who works on RTL coding is RTL design engineer. I mean, you should ideally say coding engineer, but the term doesn't look good. The RTL coding engineer, rather they use the term RTL design engineer. RTL integration, what is the person? RTL integration engineer. Okay. The next one is what? Functional verification engineer. The DFT engineer. Like that, you see, I mean, if I put together everything, these are the different people involved. Like in the house construction, we had so many people, right? Starting from the architect, the contractor, plumber, painter, masonry, many people. Here also, so many people are involved by the time chip gets manufactured. So, as in house construction, someone who works in carpenter, can he do any other work in the building? No. Here also exactly same. Someone who works into, let's say, DFT, he will never, I mean, unless he wants to really do that, company will not give him functional verification work, because that is not his expertise. What is his expertise? DFT. Like that. So this is the time where you can choose your career decision, where you want to get into, whether you want to get into front end domain, you want to get into back end domain, specifically in that domain which activity you want to get into. Again, I'm telling, don't get confused by so many terms. Why you should not get confused? You are not going to do everything. Let's say my friend, for example, he has got around, let's say, 15 or some 90, close to 15-20 years of experience. He is working into functional verification for last 15 years. He doesn't know anything about physical design, anything. If I tell him what is a macro also, he don't understand, frankly. It is still fine for him, because company doesn't bother whether he knows physical design or not. Company doesn't even bother. Only thing company is bothered about is what? How good he is with functional verification. Again, company doesn't bother whether he is good at layout or not. He doesn't even know what is analog layout, what is standard cell layout, because that is not expectation from him. So when you join into the companies, you will be given only one role. You will not be asked to work on entire thing. You will be given one specific activity. Okay. So some of the places where I have seen is that as an institute, we focus on one specific domain. Let's say you choose to do functional verification. We will try to give you only functional verification expertise. Okay, maybe RTL, these three things. We'll try to mix these three things. Okay. Someone who want to do physical design engineer, we try to give STA, physical design, physical verification expertise, because these three are related to each other. Means someone who is into physical design can learn physical verification, because they are expected to do physical verification. They're expected to do static timing analysis. But we won't mix everything. We will not mix this plus this and set up one course. I have seen that where uh, the, the resume I have seen is a physical design engineer resume. A person ends up doing some functional verification, person ends up learning some system verilog, then little bit of physical design. So the companies don't hire. I mean, it looks good for you because I'm doing everything, but companies don't want that actually. Companies don't want you to come with small expertise of everything. Rather, you should be expert in one particular domain. That is what as an institute we focus on. Yeah, Shlok, please ask your question. Are you asking question? Now let us understand. Uh, I mean, what are these job roles and how the teams will be distributed? So, if you take a typical team distribution, let's say there is a team of 50 people. Let's say you're working on mobile SoC project. That means what, you go to Qualcomm or MediaTek, there will be mobile SoC teams, because these teams, see, custom design is not included. See, custom design is included. I mean, we can, what in fact whatever you're doing physical design is a custom design only. You're implementing the design as per your requirements. What is meant by custom? Customizing for your requirements. So it's a custom design only. No, custom layout is not included, because layout is a separate topic, right? I mean, layout itself involves analog layout, IO layout, standard cell layout. We cannot mix everything. That's where I said, right? You have got a limited time of around 6 to 8 months. If you try to do everything, you will not be expert in anything. Rather, we spend this much time to become expert in one specific domain. So, to answer your question in a straightforward, the layout is not part of the physical design flow in our course. So coming back to the slide where we are talking about how this team of 50 will be distributed. Generally, front-end domain will have 25 to 30 people, which is around 50 to 60%. Out of them, how many will be the architects? One architect. Design team will be around 4 to 6 people. There will be more people in the functional verification, because you may say, why less people in design, more people in verification?
Every block
Yes.
for every head person.
Yes, I'll tell you. Thank you for that. So what happens in design is people mostly buy the IPs. There is a concept called as IP. Can someone tell me what does IP stand for? Intellectual property, right? So I want one processor IP. let's say we are talking about Qualcomm, for example. They want one processor IP. Qualcomm, instead of developing their own processor, they will go to ARM company, ARM company, and they will purchase that IP from that ARM company. So they don't have to develop it. Let's say they want DDR controller. Okay, inside the chip there will be something called as DDR controller. Again, Qualcomm won't develop their own DDR controller. They will go to Synopsys. They will buy the license of DDR controller. Let's say they want GPU. They may develop their own. They may go to some other company. So in many cases, the IPs are already available or you buy from someone else. Because of that, you don't need a big design team. If I develop everything from inside the company only, instead of 4 to 6, I may require 30 to 40 people. If I develop everything inside the company only, not 4 6, I may require 30 to 40 people. Companies are more concerned about reducing the time. They're okay to spend more money, but they want to reduce the time and come out with the product quickly. So there they go with buy IPs. Let me again repeat IP. What is IP is, I can develop my own block. That logic I can sell to other companies so that they will use it. So what is the advantage for the other company? They don't have to do all the effort that I have spent. So that is how most of the places designing works. Whereas when it comes to functional verification, we still have to verify each and everything. Whatever IPs you have purchased, whether they are working properly in your design, you still have to check it. Because you cannot ignore even a single mistake. Because if you, out of 1,000 things, even if one thing doesn't work, the chip will be useless. Out of 1,000 features, let's say my mobile phone, let's say has 1,000 features. Even if one simple feature doesn't work, my mobile phone will be useless. People won't buy because of that one issue. So that's why functional verification is important. Which constitutes almost how much percentage? 30 to 40%. Now, because it has got more people, companies will keep group of experienced freshers. Here, since there are less people, one person, will they go with fresher or experienced people? Experience. Here also, since there is only 4 to 6, they'll go with experience only. Because for them, if at all company has to reduce the cost of employees, here they have that flexibility. Other places, if they go with freshers, the freshers cannot do that advanced level work. That is where you see more opportunities coming in functional verification. You understand, right? I mean, you keep seeing job roles for functional verification. Why does it happen? It is because the companies have flexibility to keep some freshers. Next, coming to backend domain, everything remaining. See what will be remaining around 20 to 25. DFT will have 2 to 5 people. Physical design will have 10 to 15. HDA will have. So here also, physical design is where more opportunities are there. DFT has opportunities, but not as much as physical design. I mean, if you ask me, does companies don't hire for DFT in a fresher? They do hire, but less in numbers. Let me again repeat. Companies do hire in DFT for freshers, but it is not as frequent as functional verification as much as physical. One second. On a positive side, the number of people in DFT also will be less. Number of people who join training. Let's say we train 100 people in functional verification. DFT we only train 20 people. Because less requirements are there, less people join the training also. Yeah, please ask.
Sir, for functional verification, how much knowledge we need for design?
How much design knowledge you need? You need to be good with Verilog language. First
It
thing.
is coding part, like designing like that.
No, that is not what we are talking. See, design starts with Verilog understanding. You don't need to be expert in design. You don't need to be. You actually need to be very good in digital design. All the concepts of digital design, which will be covered in the course. So So this is a brief about it. So here, what is that I'm trying to emphasize is there are more opportunities in functional verification, physical design, DFT, layout. So these are the domains where freshers are generally hired. Let me again repeat: functional verification, DFT, physical design, and layout. These are the domains where the freshers are generally considered. There's one more domain, that is FPGA system design, which is, because we are talking about ASIC, I didn't show that even in FPGA system design, companies hire freshers. Let us talk about training schedule. Whatever questions you may have, I'll address towards the end of the session. Once I'm done with this, we'll talk about that. Okay. Uh, since this demo session is about functional verification, let me give you a brief about what is functional verification before we move on to the training schedule. Okay. Tell me, in the beginning of the session, I explained functional verification. What is it? Okay. It is about checking the design functionality. Let's spend few minutes to understand this. What do you see here? Ethernet IP core specification. Let me again repeat: Ethernet IP core specification. This is a document which tells how Ethernet logic works in a chip, how the frame transmission will happen, how the Ethernet frame reception will happen, how that collision will be detected. There are some logic. I won't go deep into that. Okay. So this document, what you see here, is input to two people: design engineer, verification engineer. There are two engineers involved: design engineer and verification engineer. The design engineer reads through the spec and develops something called as RTL code using Verilog. The design engineer develops something called as RTL code. RTL stands for register transfer level. Which language is used to develop this? Verilog. So let's say he develops. What is that he would have developed? I'll show you. What do you see the folder name? Verilog. So that means which language he has used for developing these files? Verilog. Like this, he has developed many files. Each file is a Verilog file. V file means what? Verilog. See, this is a Verilog file. It has got some logic. You see, it's more close to English. Always at whenever positive edge of clock happens or positive edge of reset happens, if reset is there, make MDC equal to 0. Else do something. I'm not trying to teach Verilog here. Okay. All I'm trying to tell you is that how does this logic looks like. So, in summary, this document, what you see, the Ethernet specification, explains how the Ethernet logic works. Let's say if I am a design engineer, I will read through this specification completely. Every page, every word, every line, read through. After reading through this, I develop all these files. In which language? Verilog language. Now, when I'm developing these many files, there can be some issues, right? Can I be sure that 100% I've done everything correctly? No, right? There can be bugs. Let me take one of the things. Let's say this one. It has got a lot of code. Okay, you see, it has got a lot of code. Somewhere, you see, this is inversion logic. This is not there. Idea is we should have kept the inversion logic. It got missed out. When I'm developing this code, due to some mistake, inversion should have been there. That is called as bitwise inversion. But I missed out bitwise inversion. Now, can you identify where is the bug? I give you all these files. Can you identify that? Can you tell that the MAC control line number 274 has an issue, 276 has an issue? Can you tell without doing anything? Just right. That will be called as a magic, right? Where you open something automatically and you tell on this line number there is a problem. That is what is actually the role of a functional verification engineer. What is the role of a functional verification engineer? To identify these kind of issues. But as I said, we cannot do it as a magic where you naturally go here and open this. Now I am telling this because I did the file change now. So I know that I opened Mac control, I changed line number, specific line number. Because of that, I'm able to tell that that is where the bug is there. But if I give it to someone, I call my one more friend, one more trainer, tell him where is the bug. Can he detect? No. So for that, he follows a process. That process is called as functional verification. Okay. What is the role of a person who does functional verification? He gets this whole thing as an input. Whatever code I have developed, I am the design engineer, I have developed the code which will implement the design behavior. What is the other input that person will get? This document. So two things he gets as inputs. One is what? The code, entire code that I have developed. What is the second thing? The specification, a document which will tell how the design should work. So then based on these two inputs, I follow specific process called as functional verification. As part of functional verification, we read through the spec, we list down features, we come up with a test plan, then we develop test bench architecture, we develop test bench components. The simple, it comes down to, the logic comes down to this point where this is the design code. You develop your own model. Let's say I'm a verification engineer, I develop something called as reference model. The inputs are applied to this, inputs are applied, same inputs are applied to this. What I will collect the outputs, I compare both the outputs. If they match, it is working. If they don't match, something wrong. I'm putting it in a very simple terms. Okay. Let me again repeat, where does the functional verification start? It all started with this document. First of all, who got this document? Design engineer. Okay. He uses a language called as Verilog. Using that language, what did he do? He developed so many files. He not only what you see, there are files below also. He developed so many files, which finally putting together everything gives me Ethernet behavior. It gives me Ethernet behavior. I mean, this code will be responsible for generating the Ethernet frames, sending the frames, receiving of frames, and all that. So we are not going into what is Ethernet here. We are just trying to understand what is mean by functional verification job role. Okay. As I said earlier, when we develop so many files with so many hundreds of lines, mistakes are possible, right? So let's say he has done this mistake. I right now I don't know where is the mistake comes. Somewhere here or here I did. Okay, no, here 222. The mistake was bitwise inversion operator was there, that got removed because when I'm coding hundreds of lines, I can miss out and code it. So the role of a verification engineer is to follow a process. There will be a process. That process is called as functional verification flow, which involves around 10 steps. Read the specification, list down the features, come up with the scenarios, develop test plan, develop test bench architecture, develop test bench components. Okay, all that. And through that, he would finally identify this. Okay, if at all the verification engineer has that ability to just identify, it's not possible, right? He cannot just go and tell this file has a mistake. He has to go through that entire process. So that is what we are going to do in this course, 8 months or whatever it is. Our course will be for 8 months duration. You may ask, for this simple activity, do we really require so much time? So it requires us to learn languages like Verilog, System Verilog, and UVM. We have to learn how this design works, how the verification works, everything. So that is where we spend a lot of time. Okay. You got the idea, right? At the end, you got idea what is meant by functional verification. I just showed you one issue. There can be many such mistakes. So the importance of a functional verification engineer is what? To identify any such mistakes and tell to the design team that this is the mistake you have done. The design person, what he will do again? He will fix that issue. He'll give me the updated code. That process continues till the time I say that everything is working fine. Then it goes through the next stage. That is where we'll try to understand a little bit between how the front end work will happen, back end work will happen. Back end work many times is very stressful actually, because let's say project starts in January, the chip will come out, let's say, in October. The project starts in January, comes out in October. Verification engineer work will be there almost throughout. So my work will be distributed. The backend domain, the physical design, DFT, static timing analysis, their work starts in sometime in June. It will go till October. They have to finish all that work in 3-4 months. There it becomes very stressful for them actually. Where I'm getting around 8 to 9 months to do my work, they have to do similar level of work in a 3 to 4 months, which makes it very stressful actually. Okay, any questions? So I'm telling, I didn't teach complete functional verification. I just gave you a brief idea about what does a functional verification engineer does. At the end, when I say that functional verification is completed, this code should be working perfectly fine without any bugs. If there is anything, I should have informed that this is where there's a mistake. Okay, so functional verification is not just about learning Verilog, learning System Verilog, learning UVM. Unfortunately, many institutes teach functional verification to be just Verilog, System Verilog, UVM. That is where the people who join companies find it difficult. Once you join the company, it's not anymore about Verilog and System Verilog. It's more about your magic skills that you developed. How quickly, how well you can identify the bugs in the design. That is a skill set. See, that skill set don't require System Verilog and UVM at all. That is your intelligence, that the smartness that you develop over a period of time. Over a period of time, through that expertise, the coding, the running simulations and analyzing the results, how quickly you can tell this is where the bug is there. So there we spend more time actually. We spend almost 2 months, at least 2 to 3 months, developing that expertise. Lot of places where I have seen, I don't want to name the institutes and all that, because being in my position, I cannot say some institute is bad. That's not correct, because they have their own strength. Many times that critical portion is missing, where you don't end up learning the actual functional verification work. You learn only Verilog, System Verilog, which is really not the core of functional verification. Tell me, what is the core activity of a functional verification engineer? Ability to identify the bugs. That is what misses in many places actually. We give that additional time. Now that is where our 8 months of training comes into picture. Initial 5 to 6 months, we focus on the core elements, the digital design, the Verilog, the System Verilog, and the UVM. The later 2 to 3 months, we focus on the activities where you learn the real functional verification skill set. Okay. Having said that, The training is not just a one-sided thing where only trainer teaches and you get everything automatically. It doesn't happen. Institute only puts institute role is only 30%. The student has 70% things to do from their side. It could involve you being regularly planning the things, whatever trainer teaches, you just revise the things, you work on the assignments regularly, you attend the evaluation test regularly, you try to figure out where you are missing, improvising on those things is what is the 70% we are talking about. If you just do that, right, you don't even need to spend 15 hours, 12 hours in a day. On average, if you spend 7 to 8 hours, including the time you spend in the institute, 7 to 8 hours overall. I mean, what is this in institute? Let's say you may spend 4 to 5 hours. Another, we are talking about what? 3 to 4 hours. Another 3 to 4 hours. You go home and practice. Make notes of what is being studied. Let's say today I have done a session. You should actually, ideally speaking, you should go home, sit for 10 minutes and write down a notes. What have learned today? Why is it important? Because after 7 months, 8 months, you don't remember this topic. Forget your example. My case also, I keep teaching some subject. After 1 week after teaching, if you ask me what you have taught 1 week back, I don't remember many of things. Okay, that is where actually we use presentation. The term presentation is because it helps me tell you the topics in easy manner. So you should also have simple planning. No need of 12 hours, no need of 15 hours, nothing. Simple 7 to 8 hours in a day, 4 to 5 hours what you spend in the classes, another 3 to 4 hours what you do at the home. If you just do this for 6 to 7 months, you will have a job. Now, where do people miss is people don't spend time, uh, people are not proactive. What does it mean by proactive? If you don't understand, they are shy, they don't want to ask the trainer, they don't want to talk to the mentor and get the support. Third is basic planning is missing. What is the basic planning is, you should make a notes for every topic you study, even if it is simple digital design logic. Let's say today you studied Karnaugh maps. Some Karnaugh maps has some 4 rules, let's say 4 type 5 rules. How do you group elements? Okay, let's say you are talking about De Morgan theorem, it has got around 7 8 rules. Okay, you just making a notes and writing simple examples of what is what. That planning is compulsorily required. Let me again repeat, if you don't do that level of planning, you will never get a job. Because what I have done in the first month, my training, let's say start in January, it gets over in August. So you won't remember what you have done in January. What I have done in January, February, 100% I won't remember. So how do I, does it mean that I have to do the digital design again completely? No, you have to prepare a short notes of what you have learned. While you are doing Verilog, you have to make a notes. Like that, every topic you learn, you have to make a notes. This simple planning is what is required. You maintain a notes either in a laptop, you maintain a Word document, or you maintain a proper notebook where you write down the things and just keep revising the things. If you just follow these basic guidelines, you can easily get a job. Again, in the market, there is no scarcity of jobs. There are jobs available. Even today, people are getting placed. Okay, it just that companies cannot hire just anyone. Let's say if I ask, after all the training, if I ask you, write a simple Verilog code. After all 8 months of training, if I ask, write a simple Verilog code, okay, for let's say FIFO, for a counter, if you cannot do that, company will not hire you. Because they cannot just hire you because they want to fill the numbers. They hire you because you will go there and do some work for them. So that skill set you need to develop. Okay, why am I emphasizing this? I'm emphasizing it because I'm telling you the mistakes where people do, what mistakes people do. One is they don't spend time, they are not proactive in learning. What is meant by proactive? Actively participating and getting the support from the trainer, getting support from the institute. Third is basic planning. Make a notes of the topics, keep revising the things, improvise your aptitude skills. This all what is required to get a job. Let's go back to this one. Let's talk about the training schedule. Mode of training. Training is available in full week, weekends only, weekdays evening batches also possible. For a fresher who doesn't have any other commitment, this is the suggested one. Full week training is the best option. The full week training can be done online, can be done offline, can also be done in hybrid model. Means you can anytime switch. Let's say this month you are in Bangalore, next month you want to go to native, you can still attend. So if you ask me what do I suggest, I always suggest you to attend offline mode, because that's where a trainer can see, you can interact with the trainer in person and get the all the required support. Does it mean that online you don't get the support? You do get the support. The only difference I'll tell you, trainer can see and tell you whether you're doing or not. Okay, in online I cannot see the person. Okay, in here in the classroom I am able to see you and tell you whether I can even figure out whether you are following or you are confused with the topic. In online that is not possible. Except for that, everything else is same. Even in online you get the same level of support. If you ask, I need a dedicated support session, our admin will arrange that support session. In all these cases you get the video access for revision purpose. Whatever session, let's say right now I'm doing this training, this is being recorded. This video access will be there for you for revision purpose. Now if you ask me why only two, I mean, some many times the trainer, the admin keeps access till end of the course. Let's say Verilog starts in January, it completes by February. Many times till February end the videos will be available, but the minimum we commit is 2 weeks. If you ask me why not 8 months, it is not a good idea. Why it's not a good idea? You don't want to revise January topic in August. Do you want to do that? I mean, unless you just want to do revise, the idea is you should learn the subject immediately. Within 2 to 3 weeks, you should learn. You don't want to keep January topic for May month. So to discourage that, we keep only limited period. Weekend sessions is mainly meant for working professionals. Okay, it is currently only available in online mode. But dedicated mentor will be there. Let's say if the person wants to come to institute and get the support in the institute, mentor will be available, trainer will be available. uh, Weekends only they will have access to all the recorded videos for entire course duration. Then weekdays evening batches, this is based on the minimum availability of the students. We should have a minimum batch of 5 to 6 people, then only we run evening batches. Irrespective of mode of training, whether you attend online, offline, hybrid, weekend, full week, you will have a dedicated mentor for doubt clarification. Talking about the design and verification training, I told you, right, whether you say design and verification, whether you say ASIC verification, whether you say functional verification, every course is same. So it is a 8 months course. Purposefully we have kept it for 8 months. Purposefully we have kept it for 8 months. Reason is, many times people who join the course doesn't come with the required fundamentals. Okay, we have to start with the fundamentals of what is logic gate, what is a Karnaugh maps, what is De Morgan theorem. At that level we have to start. Having said that, I cannot teach entire digital design in 2 weeks. It takes time, because what is the duration for which you do digital design in your BTech? One full semester, right? But 1 to 3 hours in a week, and 3 or 4 hours in a week. The same coursework we finish in 3 to 4 weeks, but more depth of that actually. Uh, okay. This 8 months will have around 6 days per week, 4 to 5 hours per day. This 4 to 5 hours also will be, let's say right now your digital design classes will start in the next week. 2 hours of theory, around 2 to 3 hours of problem solving session or lab sessions. So the trainer will teach you specific topic, let's say ones complement, twos complement, nines complement, tens complement, and all the related logic. During the second part of the session, we'll be giving you around 20 to 30 questions related to that. You will be working on that with the trainer support. So here, what do we mean by proactiveness is, you should be trying to do the things. Even if you don't understand one's complement, you should try to understand, you should try to solve those problems. Okay, then you take the support from the trainer. You should not expect that everything will be taught by the trainer, everything mentor will make me do. We should not come with that approach. See, the sessions could be mostly we try to keep it in the morning, but they can happen in the after lunch also. The sessions could be distributed anywhere from 9 a.m. to 5 p.m. Please be prepared for that one. Okay, don't think that always sessions can will only happen in the morning first half, because with the multiple trainers and multiple batches, sometimes sessions need to be kept post lunch also. Okay, every session recorded video access will be there for 2 weeks purpose. Why this access is being given is for you to revise and make a notes. If I do a, let's say, 3 hour session, you cannot write everything. Okay, uh, people whom I have seen, the people who got jobs immediately, okay, what they used to do is they had maintained almost 1,000 or 1,500 pages notes. Actually, the person who got job, he came to me and told me I got a job, and then he told me I went through each and every minute of the video whatever trainer has taught. I used to make a notes of everything. Okay, now he works in Qualcomm. Within 2 3 years he is in Qualcomm. The point is, that is the difference. It was his attitude, the way he approached towards the learning is what makes the difference. It's all same training for everyone, right? How do you utilize that time, resources you have, is what is important. Let me again repeat, your difference between your success and failure, what is that difference between you getting a job, not getting a job, will be the planning you are going to do. The planning I refer to, how do you make a notes, how do you how proactively you work on assignments, and how do you get the support, is all what is going to define. There are job opportunities, there are job opportunities. It's just that you need to come to that level where companies find you suitable. The companies don't expect you to be expert, because they're just hiring you as a fresher, right? Will they expect you to work as a 5 years experienced person? No. For a fresher, your basic skills should be there. First thing companies look is, you know what, attitude. Do you have the right attitude towards the work? I mean, are you willing to spend time to learn? Do you have the basic aptitude skills? Okay, are you good with the fundamentals? Let's say in digital, do you know how to solve simple combination logic? Do you know how to solve simple sequential logic? That's what companies focus on. Then they focus on advanced things. Okay, so talking about this video, we have our own learning platform called as inskill.in, where you get the all the access. So if I go to that one, those who are posting the questions, I'll be answering all those questions once I'm done with these topics. Let's say if I go to Verilog, you will get access to the live session videos, whatever sessions are happening on a date basis. 22nd June, 23rd June, you will get the video access. Presentation will be available here. Also, as our admin might have told you, we will give the hard copy of the course material. Digital, Verilog, everything will give you the hard copy. And assignments will be available here, where even the hard copy material you get there, in that also assignments will be available. Okay, these assignments are very, start from the very basics. Okay, they are not, it's not like a assignment where we tell do this. The guidance will start from simple things, like if it is a half adder, what ports are there, how to implement, how to write a test bench, step by step. So what do you need as a student? You should have that patience to read through this and at least try to do the things. Let me again repeat, as a student, what is that you require is, I'm not expecting you to do 100% of everything. That willingness to do, and proactiveness to get the support. Willingness to attempt. If you get it, good. If you don't get it, go to the trainer and get support. Anywhere you miss it, you will not get job. Again, I will repeat. Don't think that I'm talking negative. I'm giving caution to you. Where do you miss? If at all you don't get a job, why you don't get a job? You lack a willingness to attempt, or you lack that proactiveness to get the support. If you don't get it, you have to get support, right? Any of those places you miss, your skill set don't come to the level. Just joining an institute doesn't guarantee the job. Joining the institute and learning the skill set to a specific expertise is where your job gets guaranteed. So what I was trying to show you is there will be a page login where you get access to all these materials, the notes, the lab documents, everything. So one place. So rather than giving different thing in a mail or WhatsApp, we just maintain this portal where you get access to everything at one place. All course presentations, assignments, and notes are uploaded, and printed course material also provided for all modes of training. Let's talk about functional verification training. I have already explained you what is functional verification training. It is divided into 3 phases. The phase 1 will be for 3 months. Phase 2 will be for 3 months. Phase 3 will go for around 2 to 2.5 months. Phase 1 we cover advanced digital design, Verilog, Verilog design projects. We will also teach GVim text editor. In the phase 2, we teach system Verilog and UVM. We teach Linux commands and soft skill training. See, soft skill training is not phase 2, it is throughout the course. The day you join, every week soft skill training will be there. Many times you will realize that, I mean, it's natural. Even when I started, our grammar or the way we talk English or the way we write, there will be some mistakes that we need to improvise. But the reality is what? If you go to interview, your communication skills are not good, companies will not prefer to hire you. So your communication skills also matters a lot in your job scenario. I mean, when you have to get a job, your communication skills also should be good. So generally, many of our students come from non-metros. See, someone who is already in Bangalore, who is doing their engineering from Bangalore, or has done their schooling and everything from Bangalore, it doesn't really require soft skill training because they're already there. I mean, the way their education happens, they're mostly in that environment where their English and soft skills will be better. So it is meant for people who come from towns and rural background, where every week we'll have around 1 to 2 hours of soft skill training that will focus on two things. One is improvising the communication skills, which could involve how to attend the interviews, how to explain about yourself, explain about your project, how to write an emails, how to give a presentation. Okay. It will also focus on aptitude. See, many times even aptitude makes a significant impact on your getting a job or not getting. So we conduct aptitude test once every 2 weeks. That paper will be discussed by the trainer. But then it is also on you, right? I mean, you need to figure out where am I missing. Let's say we conducted aptitude for 30, you got only 10 marks. Why did I miss 20? How can I improve it? That also you should be focusing. So in summary, soft skill is not like a 1 week thing where we do at the end of the course. So you cannot can I improve all English in 1 week? No, right? It has to be gradual improvement. So that process starts from the first week itself. Then, importantly, you don't need to wait for all the things to complete to get placement support. Your placement support starts after 5.5 months. Let's say you join in January, around June, your placement support starts. You don't need to wait for 8 months to get a job support. In some, there are times where a people gets job support after 4 months itself. Let's say the person is good with Verilog and system Verilog, companies will hire. Phase 3 is the important thing where we work on multiple industry standard hands-on projects. The projects based on AXI, AHB, APB, Ethernet, MAC protocol, those kind of things. Then you also learn Python scripting. We also learn SOC flow basics. So this is all the entire coursework. Plus aptitude will be there. This summarizes everything. I could put complete everything in 6 months. Purposefully we do it in 8 months, because what we have seen is uh, if you try to finish everything very in a short durations, right, your learning quality won't be good. Okay. And having said that, if I mean, I could actually skip all this together and just keep one simple project for 2 weeks. My training will be completed in what? Around 6 to 6.5 months. But there, everyone faces the problem. Who is everyone means? You face the problem, because once you join the company expects that since you have already undergone training, they expect you to be able to do the work. Unless you do this kind of projects, right, you don't get that exposure. Actually, I showed you a few things, right? They will expect you to debug these kind of things once you join the job, which many cases, if you haven't learned, let's say talking about some other XYZ institute where you haven't even learned this skill set, there you really find it difficult. So the you will also face the problem, company will also face the problem, because they have to take you through the training again. To teach you the skills, they will again take you through the training. The third thing is institute also faces the problem. If you go to a company, you don't perform well, they will ask you which institute you are from. If you perform well also, they'll ask you which institute. In first case in a negative sense, in the second case in a positive sense. So for me, it's okay to spend another 2 months more, where we teach the subject in more depth. And when you bring you out of the institute as a better learned person, spending that 2 months is fine, as long as you learn that subject properly. Okay, but for you, the advantage, I mean, you still don't have anything to lose, because you still get the placement support after 5 to 6 months. Now you may ask, well, let's say I got a job, how do I finish this training? Companies allow you. Let's say you get job in Wipro, you tell that I still have 2 months of training, industry project I have to do. They will allow you to attend, or you can always switch to weekends only mode. Instead of doing full week, you can do to a mode where you do only on Saturday and Sunday. So the phase one and phase two helps in getting the job, because when you go to interviews, lot of time focus will be on these things only. The phase three helps you perform in the job. Actually, it is the core skill set for you. It's not system Verilog, it's not UVM. System Verilog, UVM only helps to an extent of getting a job. What is really matters to you is some real project exposure, because when you go to any company, let's say Qualcomm, Intel, anywhere, it is not about system Verilog, UVM. It is about the projects they are working on, right? Are you able to understand their project flow? Are you able to find the bugs in the design? That skill set you learn here only. Most of the other institutes, their training stops here only. Actually, what I have noticed, I mean, how do you check this part? You can check their projects. Actually, all you have to ask is what is the projects done in the course. That project complexity, you probably won't understand that project complexity, because you are new to it. Anyone who is working in the industry, you need to ask them, this is the projects I'm going to do, what is the complexity of the this course. They will tell you that. In our case, we do multiple projects. Every project you see in this list, every project you see in this list, we do these projects. Okay. For example, Ethernet MAC functional verification, you start off with everything, starting from the how to read the specification, how to list down features, each and every step we do. But the only thing is, in our case, we don't promote the person to this stage unless he is good with this. Only if he's good with the digital, Verilog, system Verilog, UVM, only if he's good, we promote him to the next batch. It could be immediately, it could be 2 months break, it could be 6 months, whatever be the time, Till the time you are not good with this phase 1, phase 2, you are not promoted to the next phase. Otherwise, what happens if you don't know the fundamentals, you cannot learn the advanced things properly. That is where institute also provides you flexibility. So it doesn't mean that you have to finish the entire course in 8 months only. You can learn it over a 1 year duration also, where you give breaks, you become expert with the subject, then you continue with the next phase. Other than this, other projects like verification IP development for AXA protocol, memory verification using test bench with configurable, FIFO, SPI controller, everything you see is done as part of our course. What is this thing will help you is it helps you develop your resume in line with the industry requirements. When you go to industry, there are many cases, let me tell you, people with this experience level have got into the jobs with 3 years experience. That is what most of our mentors do actually. Who is mentor? I'll tell you. So I'll have some supporting lab mentors, right? Let's say someone with 2020 passed out. Okay, he doesn't get fresher jobs. He does not get fresher jobs because his 4 years gap is there. Sometimes we give them opportunity to do internship here, internship or mentoring here. They do internship for 1 to 1.5 years. All they do during this 1.5 year is they teach this coursework. What you see here, they would initially teach Verilog. Teach means support. Then they support system Verilog. Then they support project. By the end of that 1.5 year, they have that much expertise where they get into the job with 3 years experience. So, in summary, if you can put the right effort, you can gain enough knowledge on par with a 3 years experienced person in the industry. Many institutes, what I've seen is they will have a small project, okay, which is not in line with the industry requirement. What is a small project, complex project? I don't want to really explain here. Uh, it's about how complex is the features, how many registers are there in the design that defines it. So let's not get into it. Just understand that we have purposefully kept the duration and the project in such a way that your learning will be relevant to the industry requirements. Experienced people, I mean, some of you may be looking for experience training if you are a working professional. The only difference is there won't be the phase 1 won't be there for you. Directly the phase 2 becomes phase 1 for you, because digital design and Verilog is skipped. We teach UVM advanced directly. Rest all things are same. So what is the difference for experienced people? Minus digital design, minus Verilog, plus UVM advanced. Other trainings like FPGA, they are all planned in the same manner. Is there anyone who has come for FPGA training here? Okay. Those attending online, anyone who has come for FPGA training? Okay, fine. Next, DFT training is also planned in the similar manner. DFT training will be for 26 weeks. The initial 8 weeks will be focused on the basics, where we cover digital design, Verilog basics, Linux, GVim. Then we teach TCL scripting. Okay. Then in the phase 2, we teach scan, ATPG, compression simulations, the first part of the DFT. In the phase 3, we do the industry projects, multiple projects. So let's another 10 minutes we will be done with this basic things, then we'll go to question and answers. So how do you choose the right course? If you are, only one thing I want to tell is, don't come with the mindset that I cannot do programming at all. Okay, don't come with that mindset that I'm from electrical triple E or EC, so I cannot do programming. Don't come with that mindset. If you are really desperate about job, better to go for functional verification. Physical design, I haven't seen much. I mean, let's say if we are able to place 6 people in DV, we are only able to place 2 to 3 people in PD. That's the reality. Uh, or in even to put in a more simple terms, everyone who has completed around 80% of course assignments in DV, we are able to 100% place them in a very good job section. You complete 80% of the course assignment, digital, Verilog, SVUVM, and the project. 100% chance that you will get a job. In PD, I cannot give the same level of guarantee because when the market doesn't hire, the companies don't hire, we cannot give that level of guarantee. But otherwise, if you want to choose, if you are comfortable with programming, let's say you have done C programming, C++, you can, I mean, you are comfortable, let's say for you to choose functional verification, you should be comfortable with programming. It has good job opportunities. In FPGA, if you want to choose FPGA, it requires medium level of programming expertise of working with the tools. It also has job opportunities. In VLSI backend domain, no programming expertise is required. You don't need any programming expertise as well. It doesn't mean that you will just get job like that. Wherever you are missing programming, you have to learn the tool and technology concepts at the same depth. If I ask you what is CMOS latch up, you should comfortably explain to me what is a short channel effect, what is hot electron effect. I mean, there could be many such things. Okay, you should be comfortable in explaining all those concepts. A front-end engineer doesn't have anything to do with it. A front-end engineer doesn't bother about what is MOSFET, what is FinFET, anything, because his expertise mostly revolves around programming and debugging the things. So let me again repeat: you're desperate about job, you're okay to willing to put the effort, go for functional verification, because based on our last 1 year experience or 2 years experience, we have been able to place any student who has completed around 80% assignments. And completing 80% assignment is not going to be very complex thing. Just have to be regular. That's all. You have to be regular. You should not deviate during the 6 to 7 months of time. If you just follow the basic things, a very good chance that you will get a job. There is a flexibility we offer. You join any course. Let's say based on my suggestion, you join functional verification. You didn't like it because you find coding to be complex. You can always switch to any other course up to 2 months, no additional fees for that. Then you may say, I will miss the 2 months subject in the new domain. It's not going to happen. Initial 1 month will be common, right? You're only going to miss second month that you join into the next batch. Let's say you are now June batch. When you want to join into a different domain, physical design, you join into the July batch. So you will continue that missed topics with them. That way you don't miss any topics in the other domain also. So you no need to repeat entire 2 months. I told you, right? 1 month will be common. 1 month you join in the next batch. So then the last set of slides, preparing for the job. First thing I told you, attitude is what is important here. You should enjoy the learning. Should enjoy learning. Let's say even at my age also I enjoy learning. What then you may say, what is the learning you have to do? Because I have to set up new courses. For example, you see here protocol. You see a list of around 10 to 15 courses there. Okay, these are all the courses which I have set up in last 3-4 years only. 3-4 years back I was working. Okay, I really didn't have time to do these courses. I was working, so most of these courses I didn't have time. Now I have a time, I learn the new things and I set up these courses. What is the advantage for me? We get enrollments. I don't just depend on fresher enrollments. For many institutes, you take out of 10, 9 institutes I will tell. For them, the fresher enrollment is the only source of their revenue. For me, it is one part of the revenue. For me, main other source happens to be the experienced people. What is the advantage with experienced people? Tell me. I don't have to provide any placements. He will come, He will enroll for DDR course, he will enroll for CXL course, AMBA course, or any course. He just does the course and done. There is no placement support, nothing expected. In a fresher, that all things are there for me. I have to prepare you for interviews. I have to take you through that additional support. So that is where, for me, this is the motivation for learning. I mean, lot of new things I have set up: interview courses, scripting courses, SOC courses. Most of these courses which we have set up in that line only. So what am I trying to tell? Even I have that motivation. I enjoy doing that. I enjoy doing that because it fulfills part of my purpose. So you should also, when you learn, you should learn it in a passionate manner where you should not immediately think about the job. That you should not think that tomorrow I should get a job. But you should be looking at, I should complete assignments and I should become expert with the subject. It is not going to be very difficult. Just follow the basic guidelines. 8 hours in a day, just follow whatever trainer is teaching, make a notes, complete assignments on time. All that you have to do. After 6 months you will see the magic. I mean, where your skill set would have significantly improved compared to where you are now. The course is structured in such a way that you start learning the problem solving skills, the programming skills, ability to understand the things in a better manner, which is all expected when you go to a job. So what is the difficult part of the training in VLSIGuru? Our institute is things quickly move. Means we finish digital design in 3 weeks, let's say. Starting from next week, by 3 or 4 weeks your digital design is completed, much more in depth than what you learned in BTech. Okay, so you need to be focused and learn that. Only important thing is that you should be revising the things time to time. After 2 months you should again be revising what I have learned in digital design, do some questions. The same planning you should do for Verilog, system Verilog. That way, when you go to interview, you cannot tell that I did this digital design 6 months back, so I forgot. I did Verilog 5 months back, forgot. Will they hire you? No, right? So it's about keeping in touch with the subject and revising the things. Right now, why I'm repeating so many times is that's the mistake people do. They don't revise. Let's say I have done one training, PCI Express training 1 year back. If I don't revise, what will happen today? I have to start fresh again. Each topic is fresh again for me. Little bit is there in my mind, but lot of things I have to revise. Whereas if I keep revising, today I don't have to put the same effort. That is one of the main reason why people don't clear the interviews and written exams. That minimum planning is required, where you have to maintain a notes, keep revising the time, revising the things on a weekly and monthly basis. As I said, in a day around 7 to 8 hours of effort is what is required. You don't need to really spend, you spend 7 8 hours, then you go out traveling in Bangalore, go around the places, all that you can do. But the minimum guideline of 7 to 8 hours you just have to maintain. We do performance tracking in a batch. When there are around 30 40 people, we have to track the performance. We track the performance based on how do you do in the assignment. Assignment is the primary criteria for us. Okay. There are times where people copy the assignments and submit many times actually. Does it help? No, right? So it's like cheating yourself only. It doesn't help. So you should not do such kind of activities. Okay. 10% is only for attendance. I don't even bother whether you come or not. As long as you complete all assignments on time, I won't even bother whether you come or not. 20% for evaluation test. For every topic, there will be evaluation test will be there. Okay. 10% presentation. I mean, we'll give a topic during the soft skill training. Our trainer will give you some topic. Let's say prepare on De Morgan theorem, prepare on sequential logic, prepare on frequency divider. Some topics they will give you. You'll have to make a small presentation and give it to a group of 5 to 10 students, so that it helps you get rid of that stage fear, how to talk, okay, how to explain the things so that other person understand. Because when you go to interviews, you have to talk and convince the other person, right? The interviewer, what is the knowledge you are telling, other person should understand. So that is the skill set you gain here. Other than that, 10% for mock interviews. Regular basis, your mock interviews will happen, where the feedback will be given, where you need to improve, all that. So you need to work on that proactively. There will be a dedicated WhatsApp group created for every student. In that group, trainer, admin, and student will be there. Basically, this is the kind of groups I'm talking. Okay, where let's say it is there. Her name is Supriya. She joined for one of the course called as Red Hawk course. Her ID is 9,605. That is the student number roughly. I mean, how many students we have trained so far, for example. Okay. So she has a issue. She posts here, and our admin supports it. It could be any kind of support. It could be a technical support. It could be admin support. The WhatsApp group helps us quickly address the issues. For example, this could be one of the issues. Okay. So I hope you got the idea. I mean, it is to make sure that you get that quick support. Okay. So what is the final? I'm going to end the session now. What is the final goal of this 8 months of training? Students should be enabled to work in the job independently. When you go to the company, you should be able to. Company should not feel that you are a burden. Company should feel that you are able to work, do the things independently. Again, let me tell you, they are not going to give you very complex things. They know that you are a fresher. They give a work according to that only. That you should be able to work independently. So this 8 months of training prepares you for that. And let me again repeat one more thing. You don't need to wait for 8 months to get a job. Your placement support can start as early as 5th month and 6th month itself. Because to know that someone is capable, I don't need to wait for 8 months. In this batch itself, in 1 week, I can tell who is capable and who is not capable. You know, right? Your teacher can tell how you learn. So it doesn't mean that remaining people I leave. I know that out of you 30% are good, 70% are bad. I'm not going to leave 70%. We try to bring up that 70% to the level. That's where this 8 months is being spent. So what is the course prerequisites? First thing is the attitude, that positiveness with which you approach the training. When you should sitting here for 3 hours or 4 hours, you should not feel it as a burden. You should feel it as the new expertise I'm developing. And the proactiveness, aptitude should be good. Basic problem solving skills should be good. Uh, this is very important. Your basic problem solving skill should be important. What is that? I mean, what is that I'm talking about? There are different categories of things in the aptitude, right? You should be able to understand those problems and solve them, because that defines how you will be able to learn the other subject. Let's say if you are not able to solve simple logical reasoning questions, you can't learn the complex topics like Verilog, system Verilog, the programming complexity involved. You won't be able to grasp that knowledge. So that aptitude is very important for you. Uh, yeah. So many cases, if you want to do a functional verification course, our institute is a good choice for you. Many cases, what happens is people join other institutes also for advanced part of the training. They again come to us. I do get a lot of at least 50 to 100 enrollments in a year where they have done the course in other institute, and then they come for advanced course in our institute. So with this, we complete the demo part of the session. Okay, one last thing, what is the skill set required is uh, whatever is required, we teach from the basics. I mean, as I told you earlier, I don't expect you to come with any skill set at all. Let's say if you ask me, should I be good with Verilog? Should I be good with Linux, digital design? Not required. If you are fine, if you are already done it, it's very good. Even if you haven't done it, we teach everything from the basics. That completes the demo. So now we can go to the question and answers. So I can take some of the questions here. those attending in classroom also, please ask your questions. Even after the training is done, I will be available if you have any questions. I'm writing down all the questions that have been asked in the chat. If I missed any question, please post your question again. Okay. First, let's go through these questions. Are the placement opportunities same for both online and offline students? Yes, it is same. Exactly same. It's just that you are attending online. Other than that, there is no difference. And can you please tell about the placement process at our institute? Like, is there any written test after the course completion, or there are direct interviews? Also, which type of companies come product and service based? Let me answer this question. Uh, so the placement process at the institute will be, at every stage we keep assessing your, another 15-20 minutes will be done. I know it's a long session, will be done in another 15-20 minutes. I'm telling to everyone actually, because 3-4 hours is a long time, I know. Okay. Can you please tell me about the placement process at the institute? uh, Placement process is based on the performance, because when we send a person to a company, let's say tomorrow Wipro comes, the Wipro will, the people who conduct the written exam and the interview, they have the value for time. I mean, they have a limited time within which they have to complete the process. If I send a person who doesn't know any basics, then they come back with a negative feedback saying that what kind of people are you sending? We always look for minimum level of expertise. I don't say that they should be completely experts. Minimum level of expertise is what we check. Okay. uh, how do we get that? How do we know whether person is having that expertise? Based on the assignments, the evaluation tests, the presentations, the mock interviews, we get all that. So then based on that we consider the people. So like you said, right, written exam is not after the course. During the course only we keep conducting tests. So based on that we know. Let's say if you are not up to the mark, we give you time, few weeks time to improvise. Then we start considering you for the placements. Most importantly, everyone who is in the institute, who has done this course, will be added into one job support group. In the job support group, everyone who has undergone training, let's say right now 237 members are there. I mean, this is the only group for our DV. DV stands for Design Verification Group. This is where, I mean, out of these 237, 10 or 12 people will be our admin and staff. So we are talking about around 220, 225 students. Okay. Though it looks a big number, but if you consider a 2-3 years period time, it's not very big as such. Okay. I mean, over a 2-3 years period of time, or even if you say last 2 years, this many people, it's still a decently small number only. Okay. Because every batch we have, let's say 30-40 people. In a 2 years, we would have trained around 600-700 people. Okay. So remaining people mostly would have got job, or they would be already working professionals who don't need job. As soon as they get a job, we remove them from the group. Okay. So this is where we post the updates. For example, specific company. In this case, there's a company who has come for the interview. This is for Wipro. So here they are giving the link where they have sent us where the student has to fill the form. So once your form is filled, the Wipro will conduct the written exam. They will take you through the interviews and they coordinate with us during this time. Okay, then they give who are all selected. This is yesterday. Okay, this is another company which is for Alphawave semiconductors. Okay, this is Wipro who are all shortlisted. They tell us these are the people who are shortlisted based on the written exam. Okay, this is one more level. Okay, this was from earlier round. This is from earlier round. The one I showed you today was yesterday's message is the new next round of hiring they are doing. Then there is another company, Prevega Semiconductors. So like this, we keep updating. I mean, someone who got selected, we keep their messages. Okay. So in summary, this is the group where you get all the updates regarding which company is hiring. We give the details where you need to apply for that link, apply for that company. And before we send the resumes to a company, our trainer will do the basic assessment. Are you able to at least answer the basic questions? Based on that only, your resume will be shortlisted and sent to the companies. So like this, for every domain, we maintain a group, and where all the information will be, all the placement support details will be posted. uh, Thing is, this placement support doesn't has any period of time. It can be for 1 year, 2 years, even 3 years. As long as you need support, you continue to get the support. For example, this group may have people who have joined in April 2023. It may even have people who have joined in 2022 as well. If I have to see this list of people, there could be a multiple set of people from different batches. April 23, then someone from uh, August 22, August 2022. Does it mean, you may ask, why they didn't get job? They didn't put the right effort. That's the only thing I would say. Because when the jobs are there, my role is what? To connect you with the jobs and to give you the right skill set. Then it is on the student to utilize that opportunity to and get the job. Next. So I hope this answers. What type of companies come? It's both product and services companies. Generally, services companies hire in bulk, 5 people, 10 people. Product companies only hire in 1%, 2%, 3% kind of things. It's both the companies do hire from us. Okay. In services, almost every company hires Wipro, HCL, Tech Mahindra, Capgemini, all those companies. In product companies, it will be limited like Synopsys or Ensilica, Onsemi, sometimes Samsung, sometimes Micron. This there are few set of companies. Even people have got placed in Qualcomm through the manager direct hiring. Siemens also hires. But let me tell you the reality. There is a good chance that you will get placed into service-based companies. After working there for 1 or 2 years, you can move to product-based companies. Career growth prospects for this domain. It's a very good domain. Very good domain. If I just look at myself, how I have done, I had a good career growth in the industry when I was working. Just that my institute was running well and I was comfortable because I don't have to answer anyone. So I got into this domain. Even while I was working for 7 years, I did both actually. I was running the institute and I was also doing the job. So that means you could see that it gives you enough time to do the other things also on a personal side. Okay. Uh, it is true in software also. Software job is also not very hectic, but the problem is salaries are not as much as in VLS. The other good thing about VLSI is once you learn a skill set, almost for 1 or 2 decades, you don't really have to upgrade much. In software, every 3 4 years they have to upgrade the new technologies. They have to keep learning new things because whatever at one point big data, Hadoop, now we don't hear much. Now it's data science, now artificial intelligence. They have to keep learning the new skill set. In VLSI, let's say someone has done DFT. DFT consists of what? Scan, ATPG, BIST. The same concepts were there in 2000 also. Same concepts are there in 2024 also. So you don't really have to learn skill set completely new. Okay. So it's a minor upskilling that you have to do time to time. Career growth prospects are good actually. I mean the salary wise, the job role wise is all good. So what we are trying to set up in the institute is to give you that right foundation for you to have a good career growth. So what is good foundation means not just learn Verilog, system Verilog, you learn the projects, the entire flow, so that you wherever you get in, you know what is what, how it is to be done. Can you please tell details for weekend course, like how does topics will be covered, how do practical sessions will happen, and also what will be the timings? Generally, weekend course will go for around 4 hours on Saturday, 4 hours on Sunday. The course weekend course is a blended mode of learning. What is meant by blended mode of learning is you have access to all the course recorded videos and the live weekend session. What we teach over the weekdays, 6 days period, I cannot do the same thing on weekends only, right? 2 days I cannot do. So then what we do is we give you access to all the course recorded videos. Over the weekends, it will be more like a revision of the topics. Whatever topics you have gone through, the topics will be revised and the corresponding revision and the assignment solving support will be provided. We cannot teach everything over the weekends. Not only here, everywhere it's not possible, because what we distribute over 6 days, doing the same thing on 2 days is difficult. So it will be a quick revision of topics. That is where you get access to all the course videos for entire course duration, so that you can watch those videos anytime and practice it. So it, of course,
In the weekend, if we have any doubt that at
yes,
any
yes.
time we
See,
can ask.
anytime you can ask. See, I told you, right? See, these are the groups where you can post your questions. I mean, for every student, there will be such a groups will be created. Let's say she has enrolled for only AXA course. Pratiksha, she has only enrolled for AXA course. For her also, we create a group where she posts her support request and our trainer will support her. Let's say someone has enrolled for FPGA course. Okay, almost 2-3 months back. This is 9,400 means almost 3-4 months back. They will get support. When we don't deny the support. So this is the group where they get all the support. Now the support is not only over the weekend. The support can be even during the weekdays also. That is the whole purpose of having the group. Because for me, the effort of solving your question is same. Whether I do on Monday or Saturday is same. But earlier I support you, earlier it is better, right? So we follow that philosophy. I hope it is clear, the person who asked this question. So someone asked me, is it only e-learning course? No. Weekend is not only video course. Weekend course is you get access to the videos plus you attend the live weekend sessions. The course fee is 63K plus GST. You can talk to the admin for the other details. Okay. When will the new batch start? The new batch starts on Monday, that is 24th of June. Okay. For initial 2-3 days, we'll be teaching some basics, the GVim basics, the GVim text editor, those things. I think mostly from Wednesday onwards, the actual course content, the digital design will start. Because why is it so is, there will be time where Monday to Tuesday also some enrollments happen. We don't want them to miss those basics, those digital design fundamentals. So we start from Wednesday onwards. So does it mean that Monday and Tuesday nothing will happen? There will also be important topics, GVim. For the people who join late, we will again revise the same topics of the digital design. Is studying Verilog, SV, and UVM for your course will be enough for cracking product-based companies? we need to study LRM. This is not really required. If you study our SV course content, that is sufficient. Why is it so? Let me tell you. If I take SV, you see our SV presentation is almost 820 pages presentation. Okay, so it covers each and every topic in depth, starting from the point what is functional verification. I mean, why are we learning SV first of all? Then the language basics. We start off with how to develop test bench, how Verilog and System Verilog differs. Then why are we learning language first of all? That level it starts off actually. Then the basic concepts of language. So now other institute. I mean, why I'm comparing other institutes is you just have to see the difference. They finish the same System Verilog course in 1 month. Okay, I take 2 months for the same course. Many times it goes beyond 2 months. Reason is not to extend unnecessarily. To do this many slides and to go to that depth, I need that much time. Right? Can I just read these slides and go to the next slide? If I'm teaching this, can I just read it and go to the next slide? No, right? I'll have to explain each and every line as a line and through an example. There we spend time. So the person who asked this question, do I have to really go through the LRM? Of course, now for the people who are new, what is LRM is language reference manual. Means when that language is released by a group of companies, they release the document. Everyone reads the document. Even I read the document and prepared this system. So for me to learn system Verilog, this is the document from where I learn. So he's asking, is our course sufficient or he has to learn? Many times, our course is sufficient. Can you tell me which projects will be done in the course? I showed you, right? Every project you see here will be done as part of the course. How many hours weekly version? I told you, right? Around 24 to 30 hours per week. In weekend course, will there be no live sessions? Live sessions will be there, right? Saturday and Sunday, both days will be there. Even during the weekdays, you can connect with the trainer and have a dedicated support session.
Sir, one more thing here. On weekend, whatever videos cover, whatever sessions covered in the week,
Yeah.
it will be available, or all videos will be available?
You have both options. Either options. You have option to go with the previous batch recorded videos where you get entire set of videos, or you have option to go with the current live batch videos.
Previous batch recorded means like all 5 months.
No. I mean, sometime in 2023, I would have done videos, entire course, that whole course videos. You get at once. Or if you want to go through the current batch videos, that also you can go through. Either of that.
But that for 1-2 weeks before.
No, 1-2 weeks, or even that could be extended. I said 2 weeks, but many times it happens till end of the course also. Next, what will students be doing in the lab sessions? What students will be doing? I'll tell you. The trainer will give you this kind of assignment. They will tell you. The trainer will tell you go through this. Sorry, it is logged out. I mean, he'll give you the assignments and tell this is the topic you need to do for next 15 minutes or 10 minutes. He'll give you time to work on that. The trainer will come to you. He'll check how you are progressing, where you are stuck, what kind of support you require. It is mostly driven from the point of view where you read the things and you try to attempt the things. When you are stuck, trainer will provide the required support. weekend course timings and also weekdays evening timings. See, weekdays evening batches will only happen if we have minimum number of students. So that please check with our team, our admin team. They will tell you whether weekend batch is there or not. If I have only 2 students, can I have a trainer do the dedicated batch? Not possible, right? So we need a minimum number. Weekend course, I told you, mostly 9:30 to 1:30 p.m. on weekends. Weekend course nothing but e-learning. Is it e-learning only? No, it consists of live sessions also. Weekday evening batch, I told you, weekday evening batch depends upon the availability of the student. It can be both online and offline, because trainer will anyway be available. He can do offline also, but it can also be attended online if at all it is there. There are some more questions, let's take it up. Okay, so few more questions, let's take it up and then end the session. Okay. uh, I have a long gap between BTech. I mean, why I am taking all these questions for some of you also. I could have asked you to leave also if you don't have questions. But some of these questions could be relevant for you also. That's why I'm making you wait. Otherwise, I could have asked you to leave because it was a long session. I don't want you to be really stressed so much. Okay. Let's go through this. As I have a long gap between BTech and this course, what are the prior knowledge required to do this course? Let me tell you, really, there is no prior knowledge required. We teach everything from the basics. Even if I go to digital design, let's say if I have to start at digital design level, we start at the level of what is uh, the logic gate, what is a truth table. uh, okay, at the very basic level, see, the code starts from the number systems, radix conversions, K maps, logic gates. See, some of you may ask a question, I have already done this, why should I learn again? You have done it almost in the first or second semester. Now you might have forgotten many things. So this is like a very good revision for you. And more importantly, in interviews, these topics are asked. If you go to interview, they check your digital design skill set. Like one person asked me, in RTL, what is the design knowledge I need to know? This is actual design expertise you should know. I mean, to become a good digital design engineer, should learn these digital design concepts very well. Okay. So to answer this question, you don't need to have any prior knowledge. You should come with the right attitude towards the preparation. Okay. I'm a older pass out. am I eligible to take admission in VLSI design and verification course? Depends upon how older pass out. Let's say anywhere after 2015 or so, you still have a good chance of getting job. After 2015, reason is there are some companies who purposefully hire people with education background. Why do they hire people with education gap? They show your gap as their internal experience. Whatever gap, let's say you are 2021 pass out, they'll hire you because you are 2021 pass out. They will internally train you. They show your 3 years gap as a internal company experience. Then they project you. Okay. Which they cannot do with a fresher, right? Someone who has 2024 pass out, can they show that any experience? So in those cases, those companies have that kind of business model actually. In weekend courses, will there be no live lab session, live online classes? I told, right, live online classes are there.
మామయ్య ఈవెన్
Are
చూడండి నేను
there any
పైన ఆరేసి
projects that
వస్తాను.
cover RTL to GDS2? Currently we don't have any projects. We don't do the entire flow. If you want to do, you can do both front end and back end domain courses. Is there any use of doing the entire flow? No, right? I told you that you should choose one particular domain and you should become expert. You choose DFT, you choose PD, you choose DV, you become expert. That is where you get a job. Next, is this domain safe from AI in the future? No, not safe. There will be always 20 to 30% job cuts will always be there. Can be there. Okay, whenever it gets fully deployed, 20 to 30% job cuts will always can be there. Now when it is going to happen, we don't know, but see, you have to be in the top 70-80%. That's true in every domain, right? When job cuts happen, you have to be in that. So that's where you have to learn the skill set in a right manner. So this is just a rough number. It can be 10 to 20% or anything, I don't know, and I cannot predict all that. But all that I can do is I have to focus on what is today and I have to learn my skill set properly, right? If you ask me, is my institute prone to any other risk? Yes. Someone else sets up a similar things with similar kind of courses with a less cost. Yes. So I cannot think about what can happen with other way, right? So I have to focus on what is my strength, and I have to just focus on that. Same suggestion I have for you also. You cannot really worry about AI much. You focus on what is happening today and try to learn the expertise. Today there is no impact. People are getting jobs, whoever is good, so there is no risk immediately. After 5 years, what is going to happen, we really don't know. Next, if I am waiting for onboarding from a company, which mode of training would you suggest? Till you onboard, go for live full week training. After onboarding, switch to weekends only mode. It is possible. You can join full week training whenever you want. You can switch to weekends only mode. Do you have any tape out projects? We don't do any tape outs. What is let me explain you the term tape out. Tape out means coming out with that file, VDS2 file. In movie, to correlate in a simple terms, what is tape out in a film industry is releasing the tapes, right? That movie film tape. Same thing, where they have done entire work, they finally generate that file. In VLSI also, you have done everything and finally releasing that GDS2 file. There will be some tape outs, base tape out, metal tape outs. Is called as tape out. We don't do that. We don't need to do that entire flow. I mean, the trainer can teach you till that stage when you join in the backend domain, where physical design, static timing analysis, physical verification. How do you do GDS2 extraction? I get good opportunities in DFT because I need to learn DFT. DFT fresher hiring has been slow, not been good really, has not been good in the last 6 months to 1 year. Okay. Though we have been connecting, the number of placements have not been very good. I mean, I don't want to hide and tell something else and all that. I'm trying to be honest to the extent possible. Okay. It doesn't mean that it should same trend should continue. It may get better. There was time where people used to get lot of opportunities. Now for some reason DFT fresher hiring has slowed down. But from the training perspective, we have a very good training in DFT. The trainer is very passionate teacher. I mean, the whole concepts and the way she provides the notes and the support, everything will make you expert in DFT. Sometimes it's the time, the patience and the time is what is important. Let's say you join into DV, no, not much patience is required. You get almost immediately if you have right skill set. If you end up in courses like DFT and physical design, little bit of patience is required, where you may take 3 months, 4 months time, 6 months time to find that right job. If we are in some other domain in VLSI for 4 years and we want to go to functional verification, will companies accept us? Yes, companies do accept. Only thing is you have to learn the new skill set. Let's say you are in PD, you want to switch to DV domain. You have to do some projects in DV. You have to learn the skill set required for DV engineer, and with that experience, with that projects, you have to try for the DV job. It is possible. Companies do accept. Can you please tell the domains details for weekend course, like how does topics will be covered and how does practical sessions will happen? And what will be the timings? I told you the timings are from 9:30 a.m. to 1:30 p.m. kind of timings on both the days. Topics will be the same topics, but it will be a quick revision. It won't be like in depth of everything. It will be quick revision, and maybe around 2 hours of revision, 2 hours of labs and assignments. This is how Saturday and Sunday sessions will be distributed. The written exam for Wipro, different companies. The written exam will be online exam or offline exam. One of the seniors in institute told we should come to Bangalore for written exams. Many times online exams are online. Let's say right now Wipro is doing, it is doing online. 70 to 80% of the companies I've seen, it has been online only. Okay. Next, lab sessions for weekend batch students. I told you, right, this is the schedule for weekend batch students. Even during weekdays, you can get support. Even you can request for weekdays. Are most placements with bond? Yes, every service company will have a bond. What is the meaning of bond? Let me explain you. Uh, the the concept of bond is, sometimes let's say some company hires you with 4 lakhs per annum salary. In services companies, how does the business model work is, let's say specific company hired you, and let's not name the company. Let's say some company hired you. They don't put you into the project from day one. They internally train you for 3 to 4 months, because they again prepare you for the client requirements, Qualcomm requirements or Intel requirements. They prepare you. So during that period, they would have paid you salary. Let's say in fifth month, while you are in fifth month of the company, let's say you get another company which pays you 5 lakhs per annum. In 80 to 90% of the companies, people don't wait, they move. So you got 4 lakhs per annum in the current company. Another company offers you 5 lakhs per annum after 5 months. You don't wait, you switch, because for you it's like another 25% or 1 lakh. For the original company, the first company, the problem is their whole 4 months effort is wasted. Money is wasted, effort is wasted, and you don't generate any revenue for them. So there they go for that minimum 3 years bond, where they spend initial 6 months to train you, to bring you up to their expectation. Sometimes they can place immediately also. Okay, so that you become productive, because it's all about investing on you and you creating value for the company. Without bond, what happens? You move immediately without waiting, because for you it doesn't matter what company has invested in you. Okay, that to save that thing risk, the companies go with bond. In product companies, what happens is, in Qualcomm, Intel, all that, they already pay you very good salaries, so you don't have a reason to move out. So there won't be any bond. So general thing is, in a product company there won't be any bond. In services companies there will be bond. That's the norm these days. what is the maximum packages that companies are providing? Generally, it can be anywhere from 3 lakhs per annum to 15 lakhs per annum, depending upon which company you get into. Get into a services company, your salary can start at 3 to 5 lakhs per annum. You get into a product company, it can be anywhere like 6 to 15 lakhs. But the good thing in VLSI is over 3 years, 4 years timeline, your salary gets normalized. Let's say whether you join product company, services company, at a 4 years experience, if you are good, you can even get 20 lakhs per annum, because you may start with 3 lakhs only. After 4 years, you could even get, I have seen people getting as much as even 30 lakhs per year. It's all about your expertise that you developed over the 4 years. What is expertise? I'll tell you. Only expertise for functional verification engineer, only expertise is, I showed you this piece of code, I told you there is a bug. What is your level of expertise? How quickly you can catch that bug? If you can catch it in 1 hour, you will get 50 lakhs also. I mean, I'm just telling you that is the level of expertise you develop, where given a code, how quickly I can develop the entire setup, entire test bench, I develop a test case, I can catch the bug quickly. I can come out with a design which doesn't have any bugs. So if you can reach that level, companies can pay you any level of salaries. So it's not about Verilog, SPUM. It's about the core expertise that comes with only practice. When we do the project, how much you explore from your side is what is important. In few more questions, we'll be done. IT experience with PS. So I have answered this question, but Abhishek is asking multiple times. I have some other domain experience in VLSI for 4 years. I've told you it is possible. Okay. Okay. Next, let's. I think last set of questions. IT experience for 3 years. Is it okay to switch now? Yes, it is okay, because as long as you are passionate about VLSI, you have a reason why you want to move to VLSI. It is okay to move, and there are many people who have done that also, who have moved from IT company to VLSI. When will the July batch start? It will start around 27th of July, the next batch of functional verification. If I have done my MTech in 2021, after that I got job as a network engineer, will I get job in design and verification? Yes, it is possible. I told you, right? When you go, even with the 2021 pass out and you work in different domain, when you apply in design verification, the companies look at your expertise level. How good are you with the design and verification is what companies will look. Okay, if you are good, even if you are 2021 pass out, 2015 pass out, companies will still hire you. So all I want to tell you is, during this 6 to 8 months, just focus on gaining your expertise. You will really see a lot of, I mean, great things happening. I mean, you don't imagine, you can't think, where a person might have started with a 5,000, 10,000 salary per month, he could be getting after 5 years 40, 50 lakhs per annum. That is the VLSI industry. In VLSI industry, there is nothing like 30% hike or 40% hike when you jump. They just give based on your expertise. So all that you should focus is, how do I become expert with this subject? I am a 2012 pass out. Can I join this course? Yes, you can also join. The only thing is you have to gain the expertise and learn the things. I mean, you can call us for more details. If you ask me, will I get a job? Will I not get a job? Answer is yes, you can get a job as long as you develop the right expertise. Next, which training mode, full week or any other, should we take to complete the course with projects as soon as possible? E-learning is the mode if you want to choose, if you want to complete the course quickly. In e-learning mode, you can do at your own pace. You get access to all the videos. You can complete the course. I mean, whom this course is meant for? Let's say someone has taken a maternity leave and they want to restart the career. Someone has quit the career and they want to restart the career for whatever reason. In those cases, if they continue with the fresher batch, they will take 8 months to complete. Rather, if they go with their own pace of learning, they can even finish the course in 3 to 4 months time. Okay, if you have time and you want to do, you can go for e-learning also. Even though it's e-learning, you will have live weekend sessions and dedicated center for support. Is PD domain placements are good or not? Is DV placements more or deep PD domain? DV placements are better than PD placements. That has been the trend for last 1 year. Okay. I mean, see, DV is like a evergreen domain. I mean, based on my understanding, I'm not telling just because I'm a DV trainer. That has been how the market has always been. It's just that only thing that you need to come out of it is that your fear of coding. That is what always stops you from taking this functional verification course. Just come out of that fear of coding. We do teach everything from the very basics. Try for 2 months. If you don't like it, you switch to PD domain or whichever other domain you want. I mean, answer in one line, yes, DV placements are much better than PD placements currently. What is the minimum project for fresher in service and minimum project for fresher in service? And I didn't get this question. Do we get more product based or service based opportunities? Mostly 90% of hiring happens, 80 to 90% of hiring into service based. Around 10 to 20% is product based. What is the minimum salary for fresher? Okay. So I told you, right, I have already answered that question. It can start anywhere from 3 to, it can be up to 15 lakhs per annum. In VLSI, only thing you need to remember is your first salary is not the real salary. After 3 years, if you ask, that is your real salary. If you start your career now, 2027, what you get is your real salary, because that is where when you jump your job, I mean switch to a new job, you get your salary what you deserve based on your performance. uh, yeah, I told you, right, I mean 80 to 90% of companies will be service based and 10 to 20% will only be product based. Okay. That is how hiring happens in the training institutes. If a company, let's say Qualcomm, wants to hire a person, they'll go to IIT and learn. Why they will go there is, many times, don't take me offensively, things are proven there. I mean, if they hire 10 people, they know that out of 10, 8 will definitely perform well. In the institute, they'll have to go through a lot of process to identify the same 8 people. For Qualcomm, the 10-20 lakhs doesn't really matter. For a company like Qualcomm, the 10-20 lakhs doesn't matter. All they need is the right person to do the job. So for that, they're okay to pay that additional money. Okay. That is how product companies work. If you ask me, so does it mean that I don't have chance to get into product company? No. After 1-2 years, you can always get in. So if you see anyone who is working in Qualcomm, Intel, Nvidia, they are not all from top colleges or anything. At least 60 to 70%, or even more than that, are from the people who have started their career in services companies, and then they have moved into product companies. So that is how you should always plan your career. Even now, don't really look at product and service First 2-3 years is not about the salary at all. First 2-3 years about gaining that expertise and getting the right foundation in your career. Then after that you get the right set of salaries. Okay, so I hope it answers all the questions. So we will stop the session here. I'll be here for another 10-15 minutes. Those who are attending classroom, you can ask me if you have any doubts. You can ask me, because I didn't get any questions. Maybe you are shy of asking the questions. All the questions came from online, right? So it doesn't happen that only online students have questions, right? So if you have any questions, I'll be here. You can come and ask me. Those attending online also, I'll be available for some time. You can ask me the questions after that.